Being safe on the worksite is all about thinking and paying attention to what you're doing. Looking out for others is how we can all get home in one piece at the end of the day.
And no matter who you work for, we all need to be following the same safety rules. And that's what we're going to be talking about in the next few minutes.
So let's start with what you'll be wearing. You've got to be properly dressed at the worksite.
At a minimum, that means hard hat, long pants, heavy-duty work boots with a non-skid sole, a shirt with sleeves, a safety vest or bright-colored shirt, and eye protection. Check your hard hat to make sure that it's in good condition. If there's tears in the suspension or holes in it, you'll need a new one.
During the course of a normal workday, you may be exposed to different types of eye hazards, including flying particles, sparks, or chemical splashes. You need to be wearing eye protection at all times. That means safety glasses, goggles, a full face shield, or a combination of the three. There are lots of jobs that require you to be wearing a full face shield over your safety glasses or goggles. And if you're cutting or welding, you'll need to have special eye protection.
Hearing protection is essential to protect you from noise. If it's hard to hear a person 3 feet away without them yelling, you need hearing protection. There are 2 types of hearing protections available: earplugs and earmuffs. In some cases, you may need to wear both.
You never get used to the loud noise. If you continue to be exposed to it, it can cause permanent damage to your hearing.
You also need the right kind of work gloves. Heavy-duty gloves will protect against rough or sharp edges, abrasive surfaces, and splinters. A lot of people don't realize that wet concrete can hurt your skin. It can cause serious burns and skin irritations, so you need to wear rubber gloves when working with concrete. And also be sure that you've got rubber boots on. If your hands or any part of your skin comes into contact with wet concrete, you need to wash the area immediately. And if you're doing anything with acids, corrosives, or solvents, you really need to be wearing the right kind of gloves.
It's a good idea to remove rings or other kind of jewelry that can catch on a corner and cause an injury. And if you're wearing a chain around your neck, it needs to be under your shirt. And if you've got long hair, it needs to be up under your hard hat. Both these things so you don't get caught in any revolving equipment.
There's a lot of heavy equipment in use on our projects, all with different hazards. Your safety vest or shirt helps make you visible to equipment operators. And no matter where you are, pay attention to your surroundings. Getting hit by a piece of equipment or a crane load is one of the leading causes of construction site fatalities.
You're required to attend weekly toolbox talks to discuss safety on the job. This toolbox talk is for you. If you have a question or a comment about safety, the toolbox talk is a great time to bring it up.
One other thing you need to be aware of is our drug and alcohol policy. It's pretty simple. We don't want you working while you're under the influence of drugs and alcohol. It's dangerous for you, and it's dangerous for everybody around you. There are times when a company might require you to take a drug or alcohol test. If you're injured or involved in some kind of accident, you will be required to take a test. It's not optional. It's on company time, and it's required.
If you test positive or refuse to take a test, you will be subject to disciplinary action, up to and including discharge.
And just so we're clear, there's no weapons of any kind permitted on the job site.
The Project Crisis and Emergency Response Plan tells you what to do if there's an emergency such as a natural disaster, a fire, a hazardous material spill, or some other kind of incident. The people who have incident commander or emergency coordinator vests are not only there to assist in the event of a crisis, but also to help answer questions or report potential hazards, quality issues, or near misses.
Other than police or other emergency personnel, they are the only people who should be giving you directions during an emergency. Don't start doing things unless you're told by a person with one of those vests on.
All injuries need to be reported. That way we can make sure and get you all the help that you need.
Likewise, if you have a near miss, that needs to be reported so we can learn from it and keep it from happening again.
There's a lot of tasks that require you to be wearing a respirator. You've got to know the materials you're working with and make sure you have the right respirator for the job. Respirators will protect you from overexposure to dust, mist, and fumes and must be matched for the exposure. If you're not sure what type of respirator is needed for the task, have your foreman contact the safety department for assistance.
The most common respirator you will use is a dust mask. Regardless of the type of respirator you use, the mask has to have a good seal around the face. This is accomplished by being clean-shaven, using both head straps and adjusting the nose piece to fit your nose. And if you're near an operation where workers are wearing respirators, you may also need to be protected.
Nearly 1,000 construction workers are killed each year on the job. That's more than 3 workers every day, and about a third of those are because of falls. All of those can and should be prevented. Any place that there's a potential fall of more than 6 feet, you need to be protected. It doesn't matter if it's an opening in the floor or around the outside of a building. The most common type of fall protection is a guardrail. Guardrails need to be constructed of either wood or wire rope and have a top rail that's 42 inches off the ground, a mid-rail, and a toe board. If you remove a guardrail, alternate fall protection must be used, and never leave an area unprotected for any period of time. You must reinstall the guardrail before you leave the area. If you're working at an elevation where guardrails don't provide enough protection, such as off a ladder near an open-sided floor, you also need to wear fall protection gear.
Another common form of fall protection is a personal fall arrest system. This includes a harness, a lanyard or retractable lifeline, and an attachment point. You've got to inspect your harness daily for cuts, tears, and frayed straps. Buckles, snap hooks, and safety latches all need to be looked at any time you put on a harness. If anything is broken or damaged, don't use it. Give it to your foreman so that nobody else uses it either.
To put on a fall protection harness, start by securing your waist buckle, then the chest buckle, next the 2 leg buckles, and finally, recheck everything to make sure that they're tight.
The most important part of a fall arrest system is the attachment point. A general rule of thumb is that the anchorage point must be capable of supporting twice the maximum load. Most fall protection manufacturers say that means at least 3,600 pounds. If you're not sure if the anchorage point can hold that much, ask your foreman. Always try to tie off above your head and make sure you limit your fall to no more than 6 feet.
When you're climbing a wall or column, you either need to use a retractable lifeline or utilize a double tie-off. The retractable lifeline, some people call it a yo-yo, will generally be attached to the upper part of the wall or scaffold, so all you have to do is attach it to your harness and start climbing.
And when you're done, remember to attach the lifeline to the base of the column so it will be there for the next person to use. If you don't have a retractable lifeline, then you need to use the double tie-off method. To do that, you need 2 lanyards.
If you're climbing a form using 2 lanyards, you start by tying off as high as possible with the first one. Climb until that tie-off point is waist high, then take the second lanyard and tie off again as high as you can before unhooking the one at your waist. Climb again until the tie-off point is waist high and continue the process until you reach your work area. And then reverse the process to come back down.
And finally, controlled access zones or warning lines and barricades are used to prevent people from coming near a fall hazard. You need to be using fall protection when you're inside the unprotected area.
Before you use a ladder, inspect it to make sure it doesn't have any broken rungs or cracked or split side pieces. If it does, don't use it. Take it out of service. Before you start climbing, check to make sure that the ladder is set on a sound base and the side braces are locked. And don't ever use the top 2 steps to stand on. If you're on an extension ladder, then the ladder hooks need to be properly set and the ladder has to be tied off. When you're climbing, always use both hands. Tools or materials need to be pulled up in a bucket or by a rope. It's the safest way to go up and down a ladder, and you'll always have at least one hand on the ladder. And be sure to face the rungs or steps when you're working off or climbing up or down a ladder.
There are lots of holes on a job site. They may be a few inches in diameter to several feet across. You gotta make sure they're marked and covered properly. Otherwise, it's a serious safety hazard. Building a proper hole cover is only half the job. You've gotta make sure it's secure, that it won't move, and that it's marked clearly.
A lot of jobs will require you to work on a scaffold.
You need to inspect it yourself. Make sure that it's on a solid footing and that it's level. And if it's more than 2 sections high, it needs to be tied off. And then the other thing that you really want to be sure of is whether the planking and supports are in good condition and the boards are secure.
And make sure guardrails are in place on any open sides and that there are cross braces. Delivering a quality project really takes a team effort. Every single part of the building is important. The quality of the concrete pour that you may be working on today impacts the quality that occurs later on, such as flooring, millwork, and equipment installation.
Just about every project that you work on is going to have a series of mock-ups constructed. There may be a 3D computer model that we'll use in our pre-installation meetings, but there will also be full-size mock-ups like this one. A wall mock-up lets us practice what we're going to build and make sure that we have all the details completely worked out.
If there's a mock-up for your part of the work, you need to review it with your supervisor to make sure you understand exactly how things are put together. Otherwise, you may end up having to tear it out and do it again. Make sure you review the drawings and manufacturer's installation guidelines with your supervisor before starting your work.
The number one problem we typically find during quality inspections is someone did not follow the manufacturer's instructions. Every product is different, and manufacturers change their installation procedures a lot. Always have a copy of their instructions available to keep you straight.
We try to cover most of this during the pre-installation meetings, and sometimes we'll even have computer-generated sequence details to show you layer by layer how things go together. Don't be shy about asking questions. We'd rather solve issues early than find a problem later.
Quality inspections are part of our normal routine. The people reviewing your work are not out to get you. They're just part of the team that's trying to prevent problems and make sure we're delivering quality construction. If you see something that doesn't appear right, tell your supervisor and let's make it right. If you've got questions about how to do something, ask the quality assurance manager assigned to the project.
Anytime that ductwork is stored on site, it needs to be kept off the floor and the ends need to be covered over. It's important that the ends are sealed, both before they're installed and then after they're in place. If we don't do that, then dirt and dust can get inside them and spread all over the building. We always wipe down the inside of ducts before they're put in place so that they are really clean.
Once we finish work in an area, we want to protect it. If you are in an area where you see work that has been covered to protect it, be extra careful. And if you see something that has gotten damaged, report it to your foreman.
Most job sites will also have a lot of trenches that we need for underground utilities or foundation. Anytime that you are working in a trench or confined excavation that's more than 5 feet deep, it has to be braced, shored, or sloped back. This includes the area between the foundation wall and earth bank. Even a large foundation excavation can become a trench once we start putting in formwork or walls.
Any excavation must be inspected every day before anyone goes into it. Do not enter a trench until a competent person has done the inspection. Most often, this will be the foreman of the team that dug the trench. Never go down into an open trench unless the excavation is properly shored, not even for a minute. Otherwise, there's the chance that if the soil gives way, you'll be buried and either be crushed or suffocate before we can dig you out. And there should always be a ladder or a ramp within 25 feet of where you're working.
It is important that you understand how to lift properly so you don't hurt your back. When you lift something, keep the load as close to your body as possible. Keep your back straight and lift with your legs. When you're carrying something heavy, don't make sudden or rapid movements, and watch out for anything that might make you suddenly have to stop or change direction. And remember to be careful when you put something down. Use your legs to lower it, not your back.
Just about everybody will use small hand tools sometime during their shift. If you're not familiar with a tool that you need to use, don't use it until you're properly trained.
The first thing to do is to really inspect the tool. Check all guards to make sure that they operate freely and don't hang up or stick. And if there's cuts, nicks, or damage to power cords, or if the grounding pin is missing on the plug, the tool needs to be taken out of service.
Electrical tools need to be grounded or double insulated. Ground fault circuit interrupters must also be provided if the tool is connected to temporary power. That includes an extension cord plugged into a permanent outlet.
And make sure that any power tool is disconnected from the outlet before you start changing attachments or making repairs.
One of the most important things to do when you're using a skill saw is to adjust the base plate to the right thickness. That way, you're less likely to have the saw kick back and hurt you.
If you're using an air compressor, you need to be sure that the hose connections are secured with a clip or tie wire. Otherwise, hoses can pop off when you're not expecting it, and it's easy for someone to get hurt.
And if you're running gasoline-powered equipment, you need to be sure that you've got good ventilation, since it'll be putting out carbon monoxide, which can be really bad or even fatal in a confined area.
And don't use a specialty piece of equipment, such as a laser or powder-actuated tool, unless you've had the proper training.
And while we're talking about electrical hazards, don't ever go to an electrical panel and start tripping breakers. There may be someone on the other end of that circuit who could be injured. So don't start throwing switches unless you know exactly what you're doing.
Someone dies from a fire every 3 hours. Most of the people die as a result of inhalation of hazardous fumes from burning materials. If you're doing any kind of cutting, welding, or anything with an open flame, you need to have a hot work permit. Those permits can be found in the J.E. Dunn trailer.
All combustible materials must be removed within the vicinity of the work. If materials cannot be removed, they must be covered with fire blankets. A fire extinguisher must be available and a fire watch posted while you're doing the work and for a minimum of 30 minutes after you're done.
Gasoline and other flammable liquids need to be stored in approved safety cans, and the cans have to be labeled so you know what's in them. If you're fueling a piece of equipment, it's got to be turned off, and you can't be smoking while you're refueling it.
Oxygen and acetylene bottles need to be chained in an upright position away from any possible ignition source. It doesn't matter if they're full or empty, they need to be treated the same. Different gases must be separated and stored a minimum of 20 feet apart or have a 1-hour firewall separating them.
You always need to know the location of the nearest fire extinguisher and make sure that you can get to it, otherwise it doesn't do you much good when you need it. Check the extinguisher to see if it is charged, but don't test it by squeezing the handle. Once you start doing that, the pressure will bleed off and it won't work when you need it. If you need to use an extinguisher, remember the word PASS. It stands for pull the pin, aim the nozzle, squeeze the handle, and sweep the nozzle across the base of the fire. And unless it's a really, really small fire, the very first thing you should do is let other people know there's a fire.
Water can cause all sorts of problems. What happens is that moisture can actually get into the materials, which can start mold growing. And if that happens, it's a big problem.
First, we clean it up. Then we check all the finished materials, the drywall, trim, or cabinets. We have to be sure that there's not any water damage to the underlying material.
If you see wet or damaged material, tell your foreman. Don't pretend that it's not there. Otherwise, we may end up with mold starting to grow in the building. We'd rather take out damaged material than risk a problem. The bottom line is that water on the job site is bad. Clean it up or tell your supervisor when you see water that doesn't belong. The exterior skin of a building will only function the right way if all the parts are properly installed. If you see something like torn flashing, missing or damaged building paper, or simply something that just doesn't seem right, stop your work and notify your supervisor. We need to get it fixed before it's covered up, otherwise it's likely to cause problems later on. Poor housekeeping is the main cause of slips and trips on projects, so the last thing to do before we head home for the day is to make sure we leave the job site as clean as possible. You're responsible for keeping your job area clean. Scrap, debris, trash, and anything else that might be a tripping hazard needs to be picked up and thrown in the trash, including anything that's on stairs, scaffolds, ramps, walkways, and all other work areas. And if you see trash in the wall cavities, ductwork, or other enclosed spaces, pick it up. Don't leave it for someone to find later.
We prohibit discrimination against any employee on the basis of race, color, sex, religion, veteran status, sexual orientation, national origin, age, disability, or handicap. We will not tolerate harassment or intimidation in any form. If you feel like you're being harassed, report it to any one of the site supervisors. If somebody is using offensive language or catcalls towards other workers or people passing by the site, that's a problem and we want to know about it. Our goal is to make sure that we all have the opportunity to succeed at work.
So that's it. That's a lot to remember.
But the most important thing is to think about what you're doing. Focus on your work, ask for help when you need it, and keep an eye out on the worker next to you so that you can both go home safe.
We're almost done here, but there's one more thing we want you to see before you go to work.
Working in trenches and excavations is among the most hazardous of construction operations, and trench cave-ins or collapses pose a serious threat to workers' lives. An excavation is any man-made cut into the Earth's surface that is formed by earth removal. A trench is a narrow excavation with a depth greater than its width, but is no wider than 15 feet. Using protective systems and safe work practices can minimize trenching hazards for workers. The biggest risk workers face during trenching and excavation work is the risk of death from soil caving in. But other potential hazards do exist, including workers falling into a trench, hazardous atmospheres caused by toxic gases, fumes, or vapors entering the trench, materials or objects falling into an excavation, such as dirt removed from a trench or tools and materials, damaged underground utilities that can expose workers to explosive or hazardous atmospheres, or electrocution or even drowning, and incidents involving mobile equipment, such as being struck by an excavator. To minimize these hazards, pre-planning must take place prior to digging to ensure safe trenching and excavation operations. Before beginning any excavation, a job site evaluation must be conducted by a competent person, which includes evaluating soil conditions to determine their stability, locating and marking existing underground utilities, which can be done by calling 811, the nationwide Call Before You Dig service, choosing the proper protective systems to prevent cave-ins, providing a safe means of entering and exiting the trench or excavation, testing for hazardous atmospheres inside the trench, identifying overhead power lines and maintaining proper safe distances, and planning for traffic control near the work area. The competent person is responsible for the safety of workers in a trench or excavation, and must inspect them daily to identify and eliminate any hazardous conditions before any worker can even enter. This is because the conditions of the trench may change daily, such as after a rainstorm. Weight of soil can vary, but a good rule of thumb is that 1 cubic yard of soil can weigh approximately 3,000 pounds, and dirt falling 6 feet can hit a worker with as much force as a pickup truck going 35 miles per hour. Therefore, all workers who enter a trench or excavation more than 5 feet deep must be protected by sloping or benching of the earth, or by shoring or shielding under the direction of the competent person. Let's take a look at each protective system. Sloping involves cutting back the trench wall at an angle inclined away from the excavation. Unless a trench is in solid rock, the walls shouldn't be vertical without support. If the dirt is granular and breaks up easily, the trench wall needs to be sloped back farther than if the trench were in clay or a more stable material. For trenches up to 20 feet in depth, you'll need a slope of 1.5 feet back for every 1 foot down, or 34 degrees, in type C soil, which is granular, sandy, and the least stable. This includes most previously disturbed soils. The maximum allowable slope is 1:1, or a 45-degree angle for soils that meet type B requirements, and the maximum slope for type A soils, such as clay, is 3/4:1, or an angle of 53 degrees. Benching is like sloping, but the sides are vertical and then cut like steps. Just like sloping, this method depends on the type and condition of the dirt. You can sometimes use a combination of sloping and benching, but benching cannot be done in type C soil. A lot of jobs have very limited space and don't have room to slope or bench the sides of the soil back. That's when protection like shielding or shoring should be used. Hydraulic shoring may be used on the job instead of sloping. This prefabricated strut and whale system, manufactured from aluminum or steel that supports the faces of the trench, is designed to prevent cave-ins. All hydraulic shoring must be designed and set up in accordance with OSHA regulations, manufacturer specifications, or engineers' designs. If the trench is 5 feet or deeper, hydraulic shores must be installed and removed without workers entering the trench. A trench box or shield is another option to keep the walls from collapsing. Trench boxes are a frequently used protective system for utility line installations, such as lateral lines. They also provide protection to workers inside the trench when sloping cannot be used. It's usually one piece, so it's easier to install than other shoring systems. Once the trench is dug, the box is placed in the hole, and the sides of the box support the walls of the trench. The box should be in good condition and be the right kind for the depth and soil type of the trench. When they are used correctly, the sides will be secure and keep workers safe inside the protective system. Regardless of the type of trench or excavation, following these additional work practices will help ensure the safety of workers. Provide a safe way to enter and exit a trench or excavation that is 4 feet or deeper, such as with ladders, steps, or ramps. If you use a ladder, make sure it's no more than 25 feet away from you so you can get to it quickly when needed. Keep excavated dirt, called spoils, as well as materials and heavy equipment, back a minimum of 2 feet from the edge of a trench to prevent anything from falling into it. Never enter a trench unless it has been inspected by a competent person, or until there is a safe way to enter or exit, and until all cave-in protective systems are in place. Test for atmospheric hazards such as low oxygen, hazardous fumes, and toxic gases when the trench is greater than 4 feet deep. Wear warning vests or other high-visibility materials when working near moving equipment or vehicles, and do not stand beneath loads handled by lifting or digging equipment. Keep heavy equipment away from trench edges and identify other sources that might affect trench stability. Locate and mark the exact location of underground utilities such as sewer, water, telephone, or electric lines prior to digging. Keep a safe distance when working near overhead power lines. And use a spotter for any hard-to-see separation distances or in tight areas. Install a barricade or fence around trenches or excavations that are left open to prevent unauthorized access. Remember, incidents involving trench and excavation hazards can often be fatal, so it's important to take all necessary precautions.
In some workplaces, there will be dangerous products. In Canada, your employer must teach you about any dangers at work. It is up to you to ask questions and make sure you understand the dangers at your job. A hazard is a danger or risk. There are many products at work that are hazardous. You must be careful when using hazardous products. If you must use a hazardous product at work, there are 4 questions to ask. What is the hazard? What safety equipment do I wear? What do I do if there is an accident? How do I get more information? Symbols can help you understand without reading. Hazardous products must be labeled with symbols. Products with one of these symbols can be dangerous. You need to know how to use them safely. It is Canadian law for companies to label all dangerous products with these symbols. This is called the Workplace Hazardous Materials Information System. For short, we say WHMIS. Let's look at the WHMIS symbols and what they mean. This symbol means that the product could explode. It should only be used with proper training and equipment. This is a symbol of an O on fire. It means that the product is an oxidizer. That means that it creates extra oxygen. Extra oxygen is a fire risk if near heat. Do not use or store oxidizers near heat. The flammable symbol means that it can catch fire. Keep products with this symbol away from heat. This symbol means gas under pressure. If the container is damaged, it may shoot or spin out of control. If a gas under pressure is released, it can be dangerous to breathe. This symbol means that the product is corrosive. Corrosive products can damage metal. It is also dangerous if it touches your skin or eyes. You must use protective equipment when using corrosive products. This symbol means the product is toxic. It can make you sick or kill you if you breathe, touch, or swallow it. A label with this symbol means the product could cause skin or eye problems. This symbol reminds you to wear protective equipment, or PPE. Products with this label are a health hazard. They can cause serious health problems if you use them a lot. This hazard symbol is used on products that can harm waters. They should not be poured down the drain. This symbol means biohazard. Biohazards can cause diseases or sickness in humans or animals. Read the labels carefully. Wear your protective equipment, like glasses and gloves, when using hazardous products. WHMIS labels must contain warnings and information about how to use them safely. Look for keywords on labels in addition to the WHMIS symbols. Your employer has to teach you about hazardous products at work. Always ask your supervisor if you don't understand how to use a product safely. Your employer does not want anyone to be hurt at work. It is your responsibility to ask questions and understand how to stay safe. Read safety labels and look for WHMIS symbols. Stay safe at work.
WHMIS training. We live in a world full of chemicals. Everything around us and in us has a chemical nature. These chemicals can harm us in one way or another, and often we are oblivious to the hazards. In some cases, we spend so much time working with chemicals that we forget that they can pose a health or safety risk. That's where the Workplace Hazardous Materials Information System, or WHMIS, comes into the picture. WHMIS was developed to increase awareness of the risks involved in chemical use and to educate workers about safe handling techniques and procedures. It is a three-part system consisting of labels, material safety data sheets, and worker training. Many consumer chemicals are not included under WHMIS, but they do require proper labeling under our food and drug laws. All workers must be made aware of the potential health risks presented by the products that they may encounter in the workplace. All WHMIS-controlled products have been divided into 6 different classifications. Some products may fall into more than one of these classifications. Class A products are compressed gases. Compressed gases may be dangerous because of the contents, since they may be toxic, flammable, or corrosive. Examples of Class A compressed gases are oxygen, nitrogen, acetylene, and even the fire extinguishers found at your workplace. A compressed gas cylinder may become a projectile if the cylinder or regulator is damaged due to the high pressure within the cylinder. Class B products are flammable and combustible. Flammable and combustible materials are hazardous due to their explosive and reactive properties. Examples include gasoline, kerosene, and toluene. Even a can of WD-40 used in the workplace can be hazardous under some circumstances. Extreme caution must be taken with Class B products, depending on the flashpoint or sensitivity to static electricity. Class C products are oxidizing materials. An oxidizing material is a fire or explosion risk if it comes in contact with flammable or combustible materials. Oxidizing materials provide readily available oxygen, causing flammable materials to burn more easily. Even products not normally flammable may burn if there is an excess of oxygen in the area. An example of Class C material that is flammable could be methyl ethyl ketone peroxide. Non-flammable oxidizing materials include chlorine, chromic acid, and fluorine. Class D products are poisonous and infectious materials and are divided into 3 classifications. The first is Class D1. This includes materials that cause immediate and serious toxic effects. These can cause serious illness or even death due to a single exposure if exposure levels are high enough. Examples include carbon monoxide, sodium cyanide, acetone, and hydrogen sulfide. Class D2 are toxic materials causing long-term chronic health effects and may cause illness such as cancer, birth defects, or respiratory problems. Examples of D2 products are asbestos, mercury, and most solvents such as acetone and benzene. The third division is Class D3, which are biohazardous and infectious materials. Products in this case are commonly found in healthcare environments or laboratories, but are also present in many other workplaces. Even a first aid situation in an industrial facility may have a potential for viral contamination. Other examples are bacteria, parasites, and allergens from plants or fibers. The fifth class is Class E, corrosive material. Corrosives are materials that can attack and destroy human tissue, clothing, and even metals on contact. Both acidic and alkaline products fall into this category. Examples are sulfuric or nitric acid, chlorine, and ammonia. Class F is dangerously reactive material. A material is classified as dangerously reactive if it reacts vigorously with water to release a toxic gas, becomes self-reactive due to shock or an increase in pressure or temperature, or if it undergoes vigorous polymerization or decomposition. Examples would include styrene, nitroglycerin, aluminum chloride, and acetone nitrile. There are 2 different labels used to identify controlled products. The supplier label, which is applied by the manufacturer or supplier, and the workplace label. Supplier labels must be placed on all controlled products sold or produced in Canada. The label must show all required information and must be printed in both English and French. The distinctive WHMIS border on the label makes identification of controlled materials easier. This border indicates that the product is controlled and may present a health or safety risk if not handled properly. The workplace label is used if an existing label has been removed or becomes hard to read or damaged. The workplace label is also used when transferring a product from the original container to a smaller container to be used by a worker. There are some exceptions to this requirement that cover reaction and process vessels, piping systems, and very small containers for immediate use. A material safety data sheet lists all of the potential hazards presented by a product. There are 9 required sections on an MSDS, although more information may be given and it may be separated into more than 9 sections. The product information section lists the manufacturer and supplier, and the intended or permissible product uses. This section includes an emergency number to call in case of accident or injury. The hazardous ingredients section details the hazardous components present in the product and in what percentage they occur. The physical data section indicates whether the product is a liquid, solid, or gas, and what it looks and smells like. The toxicological properties or health hazard section details the potential health risks posed by the product in acute or chronic exposures and generally indicates the most likely routes of entry. It is very important to understand this section as you will need to take steps to ensure your health and that of your coworkers is protected. The fire or explosion risk section indicates whether the product is flammable, and if so, under what conditions. The preventive measures section details the steps to be taken to control exposures, including engineering controls, such as ventilation, as well as any personal protective equipment that is necessary. The reactivity data section lists potential reactions with other products or chemicals, or if the product may be sensitive to sudden shocks. The first aid measures section provides the information needed for an immediate response in case of exposure. This sheet must be sent along with the worker if they need to see a doctor as a result of exposure to the product. The preparation information section details the person or group responsible for creating the material safety data sheet and the date it was prepared. This will indicate whether or not the MSDS has expired. Chemicals need to contact or enter the body in order to cause health problems. There are 4 common ways that this occurs. Inhalation is by far the most common route of entry for workplace chemicals. Anything that becomes airborne can easily be inhaled into the lungs and may pass into the bloodstream from there. Another common route of entry into the body is absorption through the skin. This is possible if chemicals touch bare skin or if the airborne vapors come into contact with skin. Ingestion of chemicals is less common, but is possible if food or drinks become contaminated. Personal hygiene is very important when handling chemical products. The last route of entry is injection, which usually happens with a needle or may be caused if a worker suffers a cut or scrape with a contaminated piece of material. It is critical that all workers understand the potential risks of product misuse and be thoroughly trained in their use. This training should be as specific to the workplace as possible. Workers must know what protective equipment to use, what procedures to follow, and what to do in case of emergency. Every chemical can pose a health or safety risk if not properly used, and every person handling chemicals needs to understand how to prevent that from happening.
Ten Wemyss pictograms. 2 of them look almost identical, but confusing them is the difference between grabbing a pair of gloves and needing a full respirator. By the end of this video, you'll recognize all 10 in seconds, including the pair that trips up even experienced supervisors. Stay for number 7. That's the one that matters most. Here's every symbol, what it actually means, and how to tell them apart. There are 10 Wemyss pictograms total. 9 use a red diamond border from the International GHS system. The 10th is unique to Canada. We'll go through all 10, starting with the ones your crew sees every day. But keep watching, because when we get to number 6 and number 7, You'll see exactly why people confuse them and how to tell them apart instantly. Getting it wrong isn't just a training gap, it's a PPE failure. Number 1, the flame. This is the most common WMIS pictogram on a construction site. If you see a flame inside a red diamond, the product can catch fire easily. It covers flammable gases, liquids and solids, aerosols, pyrophoric materials that ignite on contact with air, and self-heating substances. Where will your crew see this? Gasoline, propane, acetylene, solvents, adhesives, paints, and spray products like WD-40. The rule is simple. Keep it away from heat, sparks, and open flames, and store it in an approved flammable storage cabinet. This is the pictogram people get complacent about because they see it every day. And complacency around flammables is where incidents happen. That's number 1, the one everyone knows. But do you know which pictogram means a product can give you cancer? That's coming. Number 2, flame over circle. This is the oxidizer symbol. Oxidizers don't necessarily burn themselves, but they make other things burn faster and hotter by supplying oxygen. On site, you'll find this on oxygen tanks, certain bleaching agents, pool chemicals, and some concrete curing compounds. The critical rule: never store oxidizers near flammable materials. An oxygen leak near grease-soaked rags is a fire waiting to happen. That's why proper chemical segregation isn't just best practice. It's how you prevent fires. Number 3, gas cylinder. This means the product is a gas under pressure, compressed, liquefied, refrigerated, or dissolved. And here's something most crews don't know. The December 2022 WMIS amendments added a brand new hazard class called chemicals under pressure. Products in this class use both the flame pictogram and the gas cylinder pictogram. If you see both symbols on a single product, it means the chemical is flammable and pressurized. You'll see the gas cylinder on welding gases like argon and CO2, compressed air cylinders, propane tanks, and refrigerants. Pressurized containers can explode if heated or punctured. Store them upright, chain them in place, and keep them out of direct sunlight. 3 down, 7 to go. We're getting closer to the 2 that look almost the same, and the mistake that changes your PPE call completely. Number 4, corrosion. The pictogram shows a chemical eating through both a surface and a hand. This product can cause severe skin burns, serious eye damage, or corrode metals. Your crew will see this on battery acid, muriatic acid used as a concrete cleaner, drain openers, and industrial degreasers. The PPE requirement here is specific: chemical-resistant gloves, goggles, not just safety glasses, and face protection. And here's the part that saves careers. You need an eye wash station accessible within 10 seconds of walking distance. A splash of muriatic acid in the eyes is a life-changing injury. That's not an exaggeration. That's the reality. Number 5, exploding bomb. The product is explosive or self-reactive. Under certain conditions, it can detonate or cause a mass explosion. This is less common on typical construction sites, but you may see it with certain organic peroxides used in fiberglass work or with self-reactive chemical products. Handle with extreme care and follow storage quantities and separation distances exactly. Because this isn't a pictogram most crews see daily, it's actually more dangerous when they do encounter it. They might not recognize it. 5 down. Next up, the 2 pictograms people confuse the most. This is the part that matters. Number 6, skull and crossbones. This is the "it can kill you right now" pictogram. It means the product can cause death or severe acute toxicity from a single or short-term exposure through swallowing, skin contact, or breathing it in. You'll find this on certain pesticides, methanol, hydrogen cyanide, and concentrated industrial chemicals. Full PPE is non-negotiable. And here's the important part: know where the safety data sheet is before you handle the product, not after something goes wrong. If you're working in a space where skull and crossbones products are present, your emergency response plan needs to include specific poisoning procedures. Remember this symbol, because the next one looks almost the same, and confusing them is one of the most common WMIS mistakes in the country. Number 7, health hazard. And this is the big one, the symbol that gets confused with skull and crossbones more than any other. This pictogram shows a silhouette of a person with a starburst on their chest. It means the product can cause serious long-term health effects. We're talking about cancer, genetic damage, reproductive harm, organ damage from repeated exposure, and respiratory sensitization. On a construction site, you'll see this on certain epoxies, isocyanates in spray foam insulation, silica dust-generating products, some wood preservatives, and diesel exhaust fluid. Here's why the confusion matters. Skull and crossbones means this can kill you right now. Health hazard means this can give you cancer in 20 years. Both are deadly serious, but the response is completely different. Health hazard products often need respiratory protection, ventilation controls, and exposure monitoring, not just gloves. If your crew thinks this symbol means the same thing as the skull, they're not protecting themselves the right way. Number 8, the exclamation mark. This covers less severe health effects: skin irritation, eye irritation, skin sensitization, drowsiness, dizziness, and respiratory irritation. You'll see it on many common cleaning products, certain paints, adhesives, caulking, and degreasers. Now, less severe does not mean not harmful. Here's what catches people. Skin sensitization from a product today can mean a permanent allergic reaction to that chemical for life. Once you're sensitized, even a tiny exposure can trigger a severe reaction. So read the label, wear the recommended PPE, and don't assume this diamond means the product is safe. Number 9, environment. This pictogram shows a dead tree and dead fish. It means the product is hazardous to the aquatic environment. Here's what makes this one unique. It's not mandatory under WMIS, but suppliers may include it voluntarily on labels. You'll see it on certain solvents, pesticides, petroleum products, and industrial chemicals used near waterways. Even without the pictogram, if your crew is working near storm drains, waterways, or soil, take extra precautions to prevent spills. Provincial environmental regulations apply regardless of whether this symbol is on the label. Number 10, biohazardous infectious materials. This is the only WMIS pictogram that doesn't use the red diamond border. Instead, it uses the classic round biohazard symbol, 3 interlocking crescents in black. It means the product contains organisms or toxins that can cause disease in humans. This pictogram is less common in construction, but it's critical if your crew works on healthcare facility construction, lab renovations, remediation projects, or any site where biological materials are present. And here's the important context. This pictogram is Canada-specific. It was carried over from the original WMIS 1988 system and is not part of the international GHS framework. So if your company works across borders, your international crews may not recognize this one. The SDS will outline specific decontamination and PPE requirements. Now, most contractors think WMIS hasn't changed since 2015. They're wrong. Health Canada published significant amendments to the hazardous products regulations on December 15, 2022. The transition period ended December 14, 2025. That means every label and safety data sheet in Canada should already reflect the updates. The two biggest changes. First, a brand new hazard class called chemicals under pressure. Products in this class use both the flame pictogram and the gas cylinder pictogram. Second, updated flammable gas classifications with more specific subcategories, Category 1A, 1B, and Category 2, which changes how some welding and torch gases are labeled. Here's the bottom line. If you haven't updated your WMIS training since before 2023, your crew is working with outdated information. And that's a compliance gap an auditor will catch. So where will your crew actually encounter these pictograms? 3 places. First, supplier labels, the label that comes on the product from the manufacturer. This is the primary source. It includes the pictogram, the signal word, either danger or warning, hazard statements, and precautionary statements. Second, workplace labels, the labels your company creates when products are transferred into secondary containers. Pictograms aren't mandatory on workplace labels, but many employers include them as best practice. Third, safety data sheets. Pictograms appear in Section 2, Hazards Identification. And here's the most common audit finding we see: containers on site with missing or illegible labels. If a label is damaged or faded, that product needs to be relabeled immediately. Workers who can't see the pictogram can't identify the hazard. Let's lock these in. Here are all 10 WMIS pictograms one more time: flame flammable, flame over circle, oxidizer, gas cylinder, pressurized, corrosion, burns and eye damage, exploding bomb, explosive. Skull and crossbones, acute toxicity can kill you now. Health hazard, long-term effects like cancer. Exclamation mark, irritant and sensitizer. Environment, aquatic hazard, and biohazard, infectious materials, Canada only. If you found this useful, subscribe and turn on notifications. We publish practical safety content for Canadian contractors every week. And if you're not sure whether your WMIS training is up to date, we've got you covered. Visit safetyevolution.com and book a free 30-minute safety assessment. You'll get a complete review of your program, plus a 90-day action plan to close any gaps. Link in the description. See you in the next one. A warehouse worker in Mississauga opens a valve on an unmarked drum. Within seconds, chlorine gas fills the room. 3 workers are hospitalized. The safety data sheet was in a binder, 10 feet away. What if those workers had known what was in that drum and what to do if something went wrong? This is WMIS, the system that exists so they do. Every year in Canada, thousands of workers are injured by exposure to hazardous chemicals, burns, respiratory damage, poisonings. Some of these injuries are fatal, and almost all of them are preventable if workers know 3 things: what they're working with, what the dangers are, and how to protect themselves. That's what WMIS does, and that's what this course will teach you. Over the next 35 minutes, we'll cover the entire WMIS system, from hazard classification to safety data sheets, from pictograms to emergency response. By the end, you'll know how to read a chemical label in seconds, find critical safety information in an SDS, and respond correctly if something goes wrong. And there's one section of the SDS that most workers have never read, but it could save your life. WMIS stands for the Workplace Hazardous Materials Information System. It's been Canadian law since 1988. In 2015, Canada aligned WMIS with the Globally Harmonized System, or GHS, an international standard used in over 70 countries. Then in December 2022, the Hazardous Products Regulations were amended again to align with the 7th and 8th revised editions of GHS. That transition period ended December 14, 2025. The current system is simply called WMIS, not WMIS 2015 anymore. WMIS is built on 3 pillars: labels, the warning information attached directly to hazardous products; safety data sheets, detailed documents that tell you everything about a product's hazards, safe handling, and emergency procedures; and education and training, which is what you're doing right now. These 3 pillars work together. Labels give you the first warning. Safety data sheets give you the full picture. Training teaches you how to use both. If any one pillar is missing, a label peeled off, an SDS outdated, a worker untrained, the system breaks down, and people get hurt. WMIS creates a chain of responsibility. Suppliers, the companies that manufacture or import hazardous products, must classify the hazards, create safety data sheets, and attach proper labels before selling. Employers must ensure every hazardous product in the workplace has a label and an SDS available. They must provide WMIS education and workplace-specific training. They must update SDSEs when new information becomes available. And workers, that's you, have responsibilities too. You must participate in training. You must follow safe work procedures. You must use the protective equipment provided. And you must report any missing labels, damaged containers, or unsafe conditions. WMIS only works if everyone in the chain does their part. Every hazardous product regulated under WMIS falls into one of 2 groups: physical hazards and health hazards. Physical hazards are about what the product can do on its own. Can it catch fire? Can it explode? Is it under pressure? Health hazards are about what the product can do to your body. Can it burn your skin, damage your lungs, cause cancer over time? Understanding which group a product belongs to tells you whether the danger is the product reacting or the product harming you. Let's start with physical hazards. There are 19 physical hazard classes under the current WMIS regulations. You don't need to memorize all 19, but you need to understand the most common ones you'll encounter at work. Flammable gases, flammable liquids, and flammable solids, products that can ignite. Aerosols, pressurized containers that can burst or ignite. Oxidizing gases, liquids, and solids, products that can intensify a fire. Gases under pressure, cylinders that can explode if heated. Corrosive to metals, products that chemically destroy metal. And a newer addition, chemicals under pressure, liquids or solids packaged under high pressure, added in the December 2022 amendments. 3 classes are specific to Canada: combustible dusts, simple asphyxiants, and physical hazards not otherwise classified. Now, health hazards. There are 12 health hazard classes. These describe what a product can do to your body. Acute toxicity. A single exposure can make you seriously ill or kill you. Skin corrosion and irritation. Chemical burns or rashes on contact. Serious eye damage and eye irritation. Respiratory or skin sensitization. The product can trigger allergic reactions, asthma symptoms, or breathing difficulty. Germ cell mutagenicity. Damage to your DNA. Carcinogenicity. May cause cancer. Reproductive toxicity. Harm to fertility or the unborn child. Specific target organ toxicity from single exposure. Damages a specific organ after one contact. Specific target organ toxicity from repeated exposure. Damages organs over time. Aspiration hazard. Enters your lungs and causes damage. Biohazardous infectious materials. And health hazards not otherwise classified. Let's connect these to products you actually use at work. Gasoline and paint thinner. Flammable liquids. Propane tanks on a construction site. Flammable gases under pressure. WD-40 and spray paint. Aerosols that can burst and ignite. Pool chlorine and hydrogen peroxide. Oxidizers that intensify fire. Acetylene cylinders for welding. Gases under pressure that can explode. Battery acid and concrete cleaner. Corrosive to metals. Grain dust in a silo or flour in a bakery. Combustible dusts. And nitrogen gas in a confined space. A simple asphyxiant that displaces oxygen without any smell or warning. These aren't exotic chemicals in a laboratory. These are products on your job site right now. Now let's make the health hazard classes real. Acute toxicity. Methanol. A small amount swallowed can cause blindness or death. Skin corrosion. Concentrated sulfuric acid. It burns through skin in seconds. Respiratory sensitization. Isocyanates and spray foam insulation. One exposure can trigger permanent asthma that never goes away. Carcinogenicity. Crystalline silica dust from cutting concrete. Years of inhaling it causes silicosis and lung cancer. Reproductive toxicity. Lead. Chronic exposure damages fertility and harms unborn children. This is why painters, plumbers, and construction workers need regular blood testing for lead levels. Specific target organ toxicity. Toluene. Chronic exposure damages the liver and kidneys. These are real products in real Canadian workplaces, causing real harm, but only to workers who don't know what they're working with. Within each class, products are assigned a category, a number that tells you how severe the hazard is. Category 1 is always the most dangerous. Category 2 is less severe than 1. Category 3 less than 2, and so on. Some classes also have subcategories, like flammable gases Category 1A and 1B. Remember, lower number, higher danger. Category 1 is the worst. This is the opposite of what most people expect. Pictograms are the visual shorthand of WHMIS. They're the diamond-shaped symbols you see on labels and safety data sheets. Each one represents a type of hazard. There are 10 pictograms in WHMIS, and you need to recognize all of them. The flame. This is the most common pictogram you'll encounter. It means the product is flammable. It can catch fire easily. You'll see it on flammable gases, flammable liquids, flammable solids, self-reactive substances, pyrophoric materials, and self-heating substances. Think gasoline, acetone, propane, paint thinner. If you see the flame, keep the product away from heat sources, sparks, and open flames. The exploding bomb. This product can explode. You'll find it on self-reactive substances, organic peroxides, and certain other unstable chemicals. These products can detonate under heat, friction, or shock. Handle with extreme care, and never store them near heat sources. Flame over circle, the oxidizer symbol. Oxidizers don't necessarily burn on their own, but they intensify fire. They release oxygen, which feeds flames. Oxidizing gases like pure oxygen, oxidizing liquids like hydrogen peroxide, and oxidizing solids, if these come in contact with flammable materials, the fire burns hotter, faster, and harder to extinguish. The gas cylinder. Any product stored as a compressed gas, liquefied gas, dissolved gas, or refrigerated liquefied gas. The danger is pressure. These cylinders can explode if damaged or heated. Refrigerated liquefied gases also cause severe cryogenic burns on contact with skin. The corrosion pictogram, it shows material being eaten away. This product can cause severe chemical burns to skin and eyes on contact. It can also corrode metal. Think sulfuric acid, sodium hydroxide, hydrochloric acid. If you see this pictogram, skin and eye protection are mandatory. Gloves, goggles, face shield. Skull and crossbones. This is the most serious acute toxicity warning. This product can kill you or cause serious harm from a single exposure through inhalation, skin contact, or ingestion. These are the products where getting the PPE wrong isn't an inconvenience. It's life-threatening. The exclamation mark, a broader warning symbol. It covers less severe acute toxicity, harmful but not immediately fatal, skin irritation, eye irritation, respiratory tract irritation, narcotic effects like drowsiness and dizziness, and skin sensitization, allergic reactions. Don't dismiss this one because it looks less serious. Repeated exposure to an irritant can cause permanent damage. The health hazard, the silhouette with a starburst on the chest. This is the long-term damage pictogram. Carcinogenicity may cause cancer. Germ cell mutagenicity may damage DNA. Reproductive toxicity may harm fertility or the unborn child. Respiratory sensitization may cause asthma. Specific target organ toxicity damages specific organs from single or repeated exposure. An aspiration hazard may be fatal if swallowed and it enters your airways. These hazards may not show symptoms immediately. That's what makes them dangerous. The damage happens silently over time. The environment pictogram, a dead tree and fish. While Canada hasn't formally adopted environmental hazard classes in WMIS, you may still see this pictogram on labels and SDS. It means the product is toxic to aquatic life. Proper disposal matters. These products should never go down the drain. The biohazardous infectious materials symbol. This one is unique to Canada. It's not part of the international GHS standard. It covers organisms and the toxins they produce that can cause disease in humans. Think blood samples, cultures, clinical specimens. If you work in healthcare, laboratory, or waste handling, this one applies to you. 10 pictograms, each one a visual warning. You don't need to be a chemist to understand them. You just need to know what they look like and what they mean. If you see a pictogram you don't recognize, check the SDS. We'll show you exactly how to do that shortly. WMIS uses two types of labels. Supplier labels, attached by the manufacturer or importer before the product is sold, and workplace labels, created by the employer when products are transferred into different containers or when supplier labels are damaged or missing. Both are legally required. A hazardous product without a label is a violation and a danger. A supplier label must include 7 elements. The product identifier, the name of the product, the supplier identifier, who made it and how to contact them. Pictograms, the diamond-shaped hazard symbols we just covered. A signal word, either danger for severe hazards or warning for less severe hazards. Only one signal word per label. Hazard statements, standardized phrases that describe the nature of the hazard, like highly flammable liquid and vapor, or causes serious eye damage. Precautionary statements, how to safely store, handle, and dispose of the product. And a supplemental label element, the hatched border around the edge, which is unique to WMIS and tells you the label complies with Canadian requirements. Workplace labels are simpler. They need 3 things. The product identifier, what is it? Safe handling information, or a reference to the SDS, and the pictograms or other hazard information. If you transfer a hazardous product into a different container for use during your shift, it needs a workplace label, even if it's a temporary container. The only exception if you're using it immediately and it stays in your possession. If a label is missing, illegible, or damaged, do not use the product. Report it to your supervisor immediately. Using an unlabeled hazardous product is one of the most common ways workers get injured. You don't know what it is, you don't know what it can do, and you don't know how to protect yourself. No label, no use. Period. A safety data sheet, or SDS, is a detailed document that tells you everything you need to know about a hazardous product. Every hazardous product in your workplace must have an SDS. Your employer must keep them accessible. You have the legal right to see them. An SDS must be no more than 3 years old. If the information changes, the SDS must be updated. Every SDS follows the same 16-section format, worldwide. This means once you know how to read one SDS, you can read any of them. We'll go through all 16, but I'm going to flag the 4 sections you'll use most often, because in an emergency, you won't have time to read 16 pages. Section 4, First Aid Measures. If someone is exposed to the product, this section tells you exactly what to do. It breaks down first aid by route of exposure, what to do if it's inhaled, if it contacts skin, if it gets in the eyes, or if it's swallowed. It also describes symptoms to watch for, both immediate and delayed. In an emergency, this is the section you read first, before calling poison control, before driving to the hospital. Know where Section 4 is in every SDS at your work site. Section 6, Accidental Release Measures. A spill just happened. What do you do? This section tells you personal precautions, protective equipment to use, emergency procedures, methods for containment and cleanup. It's the difference between a controlled response and a panicked one. If your workplace handles chemicals that can spill, and most do, review Section 6 before you need it. Section 8, Exposure Controls and Personal Protection. This is the section that tells you what PPE to wear. It lists the occupational exposure limits, the maximum concentration you can safely be exposed to. It specifies engineering controls like ventilation requirements, and it details the exact personal protective equipment, what type of gloves, what type of respirator, what type of eye protection. Wear gloves is not enough. Section 8 tells you which gloves, nitrile neoprene, butyl rubber. The material matters because the wrong glove type won't protect you. Section 11, Toxicological Information. This is the section most workers have never read, and it could save your life. It tells you exactly how the product can harm you. Routes of exposure, inhalation, ingestion, skin, eyes, whether the effects are acute or chronic, and the numerical measures of toxicity, the LD50 and LC50 values that indicate how much of the product is lethal. This section turns a vague "it's dangerous" into specific, actionable information about exactly how it's dangerous. The other 12 sections are still valuable. Here's what they cover. Section 1, Identification, the product name and supplier contact information. Section 2, Hazard Identification, the classification, pictograms, signal word, and hazard statements. This is basically the label in text form. Section 3, Composition and Ingredients, what's actually in the product. Section 5, Firefighting Measures, what to use to extinguish a fire involving this product. Section 7, Handling and Storage, how to safely work with it and where to keep it. Section 9, Physical and Chemical Properties, boiling point, flash point, appearance, odor. Section 10, Stability and Reactivity, conditions to avoid and incompatible materials. Sections 12 through 15 cover ecological information, disposal, transportation, and regulatory information. And Section 16, Other Information, including when the SDS was last updated. You won't need these every day, but know they exist. In practice, here's how to use an SDS quickly. Before you start working with a new product, check Section 2 for the hazard summary, Section 8 for the PPE you need, and Section 7 for handling precautions. If someone is exposed, go straight to Section 4 for first aid. If there's a spill, Section 6. If there's a fire, Section 5. You don't need to read all 16 sections every time. You need to know which section answers your question and go there directly. Think of it like a reference manual, not a novel. One more thing about safety data sheets. You have the legal right to access the SDS for any hazardous product in your workplace. If you ask for it and it's not available, that's a violation. Your employer must make SDSs readily available, not locked in an office, not on a computer you can't access, available when and where you need them. How do hazardous products actually get into your body? There are 4 routes of exposure. Inhalation, breathing in vapors, gases, dusts, or mists. This is the most common route of exposure in most workplaces. Skin absorption, chemicals passing through your skin into your bloodstream. Ingestion, swallowing a product, often accidentally through contaminated hands, food, or drinks. And injection, a product entering through a cut, puncture, or wound. Understanding the route tells you how to block it. Exposure effects fall into 2 categories. Acute effects happen immediately or within hours. Burns, dizziness, nausea, difficulty breathing. You know something went wrong because you feel it right away. Chronic effects develop over weeks, months, or years of repeated exposure. Lung disease, organ damage, cancer. You don't feel chronic effects happening. That's what makes them more dangerous. By the time you have symptoms, the damage is done. This is why exposure limits exist, and why PPE isn't optional even when you feel fine. How much exposure is too much? That's what occupational exposure limits tell you. An OEL is the maximum concentration of a chemical that a worker can be exposed to over a defined period, usually an 8-hour workday. In Canada, each province sets its own limits, often based on the American Conference of Governmental Industrial Hygienists, or ACGIH, threshold limit values. There are 3 types: the TLV-TWA, the time-weighted average over 8 hours; the TLVS-TEL, the short-term exposure limit, usually 15 minutes; and the TLVC, the ceiling, the concentration that must never be exceeded, even for an instant. You'll find these numbers in Section 8 of the SDS. They exist because a product might be safe at low concentrations but deadly at high ones. Let's make this concrete. A painter sprays solvent-based paint in a poorly ventilated room, inhaling toluene vapors for 8 hours. Acute, headache, dizziness. Chronic after years, liver and kidney damage. A cleaner uses industrial degreaser without gloves. The solvent absorbs through their skin. Acute, redness and irritation. Chronic, dermatitis that never fully heals. A mechanic eats lunch without washing their hands after handling brake cleaner. Ingesting trace amounts of chlorinated solvents. These aren't dramatic chemical plant explosions. They're everyday exposures that happen because someone didn't know or didn't take it seriously. PPE is important, but it's actually the last line of defense. The hierarchy of controls ranks protective measures from most effective to least effective. Elimination. Remove the hazardous product entirely. Can you use a non-hazardous substitute? Substitution. Replace a more dangerous product with a less dangerous one. Engineering controls. Isolate workers from the hazard using ventilation, enclosures, or automation. Administrative controls. Change how people work. Limit exposure time, rotate workers, post warning signs, and finally personal protective equipment. Gloves, respirators, goggles, coveralls. PPE is the last resort because it depends entirely on the worker using it correctly. A respirator in your locker doesn't protect your lungs. When PPE is required, Section 8 of the SDS tells you exactly what to use. Eye protection, safety glasses, splash goggles, or a full face shield, each for different hazard levels. Hand protection, the specific glove material and thickness. Respiratory protection, whether you need a dust mask, a half-face respirator with chemical cartridges, or a supplied air respirator. Body protection, chemical-resistant apron, coveralls, or a full chemical suit. Using the wrong type of PPE is almost as dangerous as using none. A dust mask does not protect against chemical vapors. Latex gloves do not resist most solvents. Check the SDS. PPE only works if it's in good condition. Inspect your equipment before every use. Check respirator cartridges. They have expiry dates and limited service life. Once a cartridge is saturated, it stops filtering. Chemical gloves degrade over time. Check for cracks, discoloration, or stiffness. If a glove feels different than it did when new, replace it. Safety goggles must seal properly against your face. Scratched or fogged lenses reduce your ability to see hazards. And know the limitations of your PPE. A half-face respirator with organic vapor cartridges does not protect against all chemicals. It protects against the specific chemicals that cartridge is rated for. The SDS tells you what you need. Make sure what you're wearing matches. No matter how careful you are, emergencies happen. A container breaks, a valve fails, a coworker is exposed. The next 60 seconds matter more than the last 60 minutes of safety training, but only if you know what to do before it happens. Chemical spill. Step 1. Get yourself out of immediate danger. Don't rush in. Step 2. Identify the product. Read the label or check the SDS. Step 3. If it's safe to do so, contain the spill. Use absorbent material, dikes, or the spill kit your workplace should have. Step 4. Notify your supervisor and anyone in the area. Step 5. Don't clean up a spill you're not trained or equipped to handle. Some chemicals require specialized hazmat response, not a mop and bucket. If you or a coworker is directly exposed, skin contact. Remove contaminated clothing and rinse the affected area with water for at least 15 to 20 minutes. Eye contact, use the emergency eye wash station. Rinse for at least 15 minutes. Hold the eyelids open. Inhalation, move to fresh air immediately. If the person is not breathing, call emergency services. Ingestion, do not induce vomiting unless the SDS specifically says to. Call poison control. In every case, bring the SDS or the product label with you to medical treatment. The doctors need to know exactly what the product is. The most important emergency response principle, know before you need to. Read Section 4 and Section 6 of the SDS for every hazardous product you work with regularly, before there's an emergency. Know where the eye wash station is. Know where the spill kit is. Know the emergency number for your facility. When something goes wrong, you don't have time to learn. You only have time to act. Under Canadian Occupational Health and Safety Law, you have 3 fundamental rights as a worker. The right to know. You have the right to be informed about hazards in your workplace. This is the foundation of WHMIS. The right to participate. You have the right to be involved in health and safety decisions and to participate in the Joint Health and Safety Committee. And the right to refuse unsafe work. If you believe a task poses a serious and imminent danger to your health or safety, you have the legal right to refuse. You cannot be disciplined or fired for exercising these rights. With rights come responsibilities. As a worker, you are legally required to attend WHMIS education and training when provided, use hazardous products safely and follow the instructions on labels and SDSEs, wear the personal protective equipment your employer provides and requires, report to your supervisor if you see a missing label, a damaged container, or a situation that puts someone at risk, and ask questions if you're unsure about a product. Never assume a chemical is safe because it looks harmless or because you've used it before without problems. The one time you skip the label could be the time it matters. And your employer has obligations to you. They must maintain an up-to-date inventory of all hazardous products in the workplace. Keep current SDSEs accessible, within the workplace, not in a head office somewhere else. Ensure all containers are properly labeled. Provide WHMIS education and workplace-specific training, and provide the PPE required by the SDSEs. If any of these are missing at your workplace, you have the right to raise it with your supervisor, your health and safety committee, or your provincial occupational health and safety authority. If you've taken WHMIS training before, here's what's changed and why you're taking it again. In December 2022, Canada amended the hazardous products regulations to align with the latest global standards. The transition period ended December 14, 2025, meaning all products in Canadian workplaces must now comply with the amended regulations. This isn't a minor update. The changes affect hazard classes, labels, and SDSEs. The key changes you need to know. A new physical hazard class, chemicals under pressure, for liquids and solids packaged under high pressure that don't fit the aerosol or gas cylinder categories. The flammable aerosols class is now simply called aerosols, with a new category for non-flammable aerosols. Flammable gases category 1 is now split into 1A and 1B. Pyrophoric gases and chemically unstable gases are now classified under flammable gases category 1A instead of being separate. And several health hazard classification criteria have been refined for better accuracy, including reproductive toxicity and water-activated toxicants. What this means for you as a worker: you may see new pictograms on products you've used before. SDSEs may have additional information elements. Labels may look slightly different. The core system hasn't changed. Labels, SDSEs, and training still work the same way. But the details within that system have been updated to be more precise and more globally consistent. If you notice a product's label or SDS looks different from what you remember, that's the amendment in action. Read it, don't assume the old information still applies. Let's bring it all together. WHMIS is a system, and every part of it connects. Hazardous products are classified into physical and health hazard groups, with specific classes and categories that tell you what the danger is and how severe it is. Pictograms give you instant visual identification of the hazard type, 10 symbols that are the same worldwide. Labels, supplier and workplace, give you the first line of information, what the product is, what it can do, and how to handle it safely. Safety data sheets give you the full picture. 16 sections covering everything from first aid to toxicology. Your employer provides the training, the labels, the SDSEs, and the PPE. You use them, and you have the legal right to all of it. If you remember 5 things from this course, make it these. 1. Read the label before you use any product, every time. 2. Know where the SDSEs are at your worksite, and know how to find sections 4, 6, 8, and 11. 3. Recognize the pictograms. They're your first warning. 4. Understand how chemicals enter your body, inhalation, skin, ingestion, injection, and use the right PPE to block each route. 5. You have the right to know, the right to participate, and the right to refuse. Use those rights. Remember the warehouse worker from the beginning? An unmarked drum, chlorine gas, 3 people hospitalized. The SDS was 10 feet away. WMIS exists so that you never have to be in that room, uninformed, unprepared, and unprotected. The information is there, the training is here. Now it's on you to use it. Thanks for watching. If this course was useful, subscribe for more safety training content. Visit safetyevolution.com for additional resources.
When a typical cylinder is filled to its design pressure of 2400 psi, it will contain almost 300 cubic feet of atmospheric pressure gas, or about 160 times the internal volume of the cylinder. This compression of gas represents a tremendous amount of stored energy. If the outlet valve is broken off, the sudden release of compressed gas can turn the cylinder into a missile with energy to shoot through a cinder block wall. In one reported incident, a damaged cylinder penetrated 2 sheet metal walls before becoming airborne and exiting through the roof. The tank reached an altitude of 140 feet before falling back through the building's roof a second time. When a steel cylinder becomes a projectile, it can move with great force, at high speeds, and in unpredictable directions, with the potential to cause serious or fatal injuries.
We need to train workers on how to figure and calculate their fall clearances and their fall distances correctly, how to look at the devices that they're being provided and come up with what that needed fall clearance is, and also train them on how they need to anchor and where their anchors need to be so that they're staying adequately protected. They need to be trained on all the different areas where they are going and working at heights, on what the approved anchor points are in those areas. They need to be trained on the difference between fall arrest and fall restraint. We need to train workers to be more competent in thinking, can I bring up an idea of guardrails here? Can I deny access in this situation instead of having to put myself in that fall arrest? We need to look at the inspection of the equipment and making sure the equipment is properly inspected. There's a lot of legacy equipment out there from various manufacturers that may not meet the gate strength requirements. And the people doing the training to the workers have to make sure that they're qualified to do the training. There's a higher level of education needed for the people who are training the workers, or higher level of understanding on how to train and what type of content should be trained on as we're training the workers who are using fall protection equipment.
Let's take a moment to summarize the topics to cover in your fall protection training. So your training must include the nature of fall hazards in the work area and how to recognize them, the correct procedures for using, installing, maintaining, disassembling, and inspecting the fall protection systems being used, the limitations and capabilities of the equipment being used, manufacturer's instructions and the importance of following them, the correct procedures for the handling and storage of equipment and materials, and finally, the employee's role in the employer's fall protection work plan. For more information on fall protection training requirements, please reference the Oregon OSHA standard that applies to your work activities, whether that's in general industry, construction, scaffolding, steel erection, agriculture, or other activity. There are separate standards for each of these, and you can view them on our website, osha.oregon.gov. What is fall protection? Ask 10 different people what fall protection means and you're likely to get 10 different answers. For many in the construction industry, equipment that comes to mind are things like guardrails, personal fall protection systems like fall arrest, or perhaps safety nets. But fall protection is more than equipment. Fall protection is anything you do to eliminate and prevent falls or make sure that workers who do fall are not injured. Fall protection is not just a system. It's how you look at a job or task. Beyond that, you could even say it's a commitment. There were companies using fall protection in the form of safety nets at work sites before OSHA was established. Why would they do that? The reason is because human life was valuable to them. Coming home to their families at the end of each day meant something to them, and it should to you too. Whether you are an employer or an employee, we all play a part in workplace safety. At a basic level, here's what a fall protection system is comprised of. Identifying and evaluating fall hazards. Eliminating fall hazards before considering other options like fall arrest. Implementing appropriate systems for each situation. Inspecting and maintaining those systems. Training workers appropriately, and of course, understanding Oregon OSHA's fall protection rules. We'll go into more detail about what these components mean to you over the next few modules.
Hi, I'm Greg Brown.
And I'm David Ivey, and this is Dynamic Discussions.
This is another installment in a weekly video series we're bringing you about safety products and how to use them. This week's question is, why is it better to work in fall restraint than it is to work in fall arrest?
First, we need to understand the difference between fall arrest and fall restraint. So fall arrest is where you're tied off to a personal fall arrest system and you actually have the ability to fall over an edge. If you're working fall restraint, depending on if it's active or passive, either you're tied off to a personal fall arrest system and you can't get to an edge, that's going to be active fall restraint. And then passive fall restraint is using something like guardrail, so you physically can't get over an edge. There's a barrier there.
Yeah, and so there's several different stages of the preference. We call it the hierarchy of fall protection. Number one is eliminate the hazard. Is there a way that you don't have to do that task? Is there a way that you can take what the hazard is, bring it to ground level? If that's not an option, then you go to restraint. The first restraint is passive, so you don't even have to wear a personal fall arrest kit on that. You're not in a harness because you're not in the neighborhood of a fall. Then you go to an active restraint where part of your PFAS is preventing you from getting to the area where you would have a fall. Then you move to arrest, where you can experience a fall, but your fall would be arrested. Then you go to controlled access zone, where there are markings or labelings preventing you from going to a certain area, but no PFAS on that one either.
So when looking at fall arrest versus fall restraint there, obviously fall restraint is going to come before the fall arrest in the hierarchy control. So if you have the availability to work in fall restraint, that's when you're going to do it instead of fall arrest.
Welcome to another SureWorks information video. My name is Tim McCursey, and I've been around the industry for in excess of 25 years. I've been involved in writing standards, improving standards to ensure that people are using the proper product when working at heights in the industry. The problem is, over the years, as we write and improve standards to have excellent product in the field, people do not use the product properly. One issue in the field is donning a harness. If a harness is not worn properly and you fall into it, you could seriously hurt yourself or be killed. So today, we're going to run through the proper donning of a harness. Okay? Now, prior to donning a harness, it is extremely important that the end user go through and inspect their harness before donning. Very important. When we don our harness, we want to make sure that all of our buckles are disconnected. We simply put the harness on over our shoulders. We connect our chest buckle. We connect our leg buckles. We ensure that our dorsal D-ring is positioned between our shoulder blades at the back. Now we can feel that, or we can have a buddy help us position it. Once that's done, we position our chest strap. We want it mid-chest. If it's too high and we fall into it, it could choke us. If it's too low and we do a head-first fall, we could fall out of it. So positioning the chest strap is important. We then position our leg straps and adjust our leg straps to fit. Proper adjustment of a leg strap is to be able to get a flat hand between the webbing and your leg on both sides. Not a fist, a flat hand. Okay? In addition, when we get properly fitted, the plastic belt keepers that are included on the product must be pulled down right above the buckles. The purpose of that is to keep the webbing in place so that as you move around during the day, the webbing doesn't back off and loosen. That is very important, and a lot of people don't know or understand the use of those. The other thing that is very important for us is to ensure that once it is donned, we have a buddy that is working with us, ensure that everything is positioned properly before we head up to working at height. Have a safe and productive day.
You know what they say, it's not the fall that gets you, it's the sudden stop. And of course, the farther we fall, the more forceful and damaging that sudden stop becomes. Surviving the fall, the proper use of your personal fall arrest system. The proper use of a personal fall arrest system allows a worker to survive a fall with minimal injury by not only preventing the falling worker from hitting the ground, but also by limiting the amount of force imparted onto the worker when the fall is arrested. During this program, we're going to provide an overview of the proper use of your personal fall arrest system, while also pointing out some common mistakes you should avoid. The personal fall arrest system consists of three main components.
Self-retracting devices, or SRDs, are also often used in fall protection systems because they allow you more flexibility of movement and reduce the free fall hazard because the lifeline is always under tension. In other words, there is no slack in the line, regardless of where you tie off. This added flexibility of movement does increase the possibility of swing fall. You'll see this when Abel steps off the platform. The further you walk away from your anchor, the more you will swing back toward it and then away from it in a pendulum-like motion as you fall, until you finally come to rest directly below your anchor. Although Abel wasn't injured during his last swing fall, he would have been if any obstruction had been in his swing path. You'll see an example of this in our next demonstration. Don't worry, Abel, we'll stop the animation at the moment you contact the wall. You won't have time to feel a thing. Ooh, sorry about that, Abel. I guess we weren't fast enough. Let's just pretend that didn't happen. You also need to consider that as you fall, your body picks up speed. So the farther you drop and swing into the path of an object, the greater the force will be when you hit it. The difference in height from the time you fall to the point where you hit an object is considered your swing drop distance. Swing drop distance is calculated assuming a circular or pendular motion of the worker's D-ring on a fixed and taut length of lifeline. It does not include a drop in height due to freefall or deceleration distance. To protect workers from this hazard, some jurisdictions have legislation in place that requires workers to limit this swing drop distance to 4 feet. To minimize swing fall, you must work as directly below your anchor as possible and ensure that your swing drop distance does not exceed 4 feet. When using a self-retracting device, you must also be aware of how your clearance required can be affected by your movement away from your anchor. First, let's determine your clearance if you are directly below your anchor. You do this by checking your SRD's label for its maximum arrest distance or deceleration distance. This is the additional distance that the lifeline will deploy as it engages and arrests or stops your fall. The maximum arrest distance on this unit is 1 meter or 39 inches, which is 3.25 feet. Once you have this, you need to add 1 foot to account for your D-ring slippage as your harness stretches. and then add at least a 2-foot safety margin. Adding these together will give you the clearance you require from the platform or floor, as long as you are working directly below your anchor. For every additional foot of life safety rope that is pulled out as you walk away from your anchor, you also need to add this to your clearance, since you will swing back below your anchor when you fall. Let's take a look at 2 examples. First, we'll have Abel standing directly below his anchor. His SRD's label states that the arrest distance is 3.25 feet. The first action when he falls is the sliding of his D-ring as the equipment pulls taut, so we know he will fall at least 1 foot. The next action will be the deceleration of his SRD, so we need to add in the maximum arrest distance of 3.25 feet as listed on his unit. Lastly, we need to add at least a 2-foot safety margin, and we get a total clearance required of 6.25 feet from the platform or floor. This time, let's see what happens when Abel walks away from his anchor, thereby stretching out an additional 4 feet of lifeline. To find the clearance now, we just need to add the extra 4 feet to the 6.25 feet he would need when he was working directly below his anchor. So the clearance required now is 10.25 feet. In summary, it's your responsibility to minimize the hazards of swinging by working as directly below your anchor as possible. Be aware of possible objects you might hit if you fall and swing. Set up your equipment to ensure you limit your swing drop distance to 4 feet or less. Determine your clearance required and factor in the additional length of lifeline that has been pulled out as you've walked away from your anchor. Keep this additional length to a minimum. And always inspect and use your equipment as required by the manufacturer.
In this section, we will examine the types of falls, their hazards, and how to reduce the risk of injury in each scenario. Free fall is the distance from the point where the worker starts falling to the point where the worker's fall arrest system begins to slow him down. The greater the free fall, the greater the deceleration and total fall distance. You can minimize the free fall by anchoring above your head as high as possible, using the shortest lanyard length possible. In this demonstration, a worker is connected to an anchor point above his head, but he has positioned himself off to the side of the anchor point and accidentally slips off the edge of the work area. His fall arrest system stopped his fall. However, due to the angle, his fall caused him to swing like a pendulum. In this situation, the fallen worker only needs to be rescued because he didn't strike anything on the way down. In this second demonstration, we recreated the same fall as before, but this time the worker is anchored to a steel I-beam at his feet. This is a much more dangerous fall because the greater the angle from your anchorage, the wider your swing fall will be, and the greater the impact when you contact obstructions. In this demonstration, the worker falls significantly farther faster before slamming into a wall below, causing serious injury. In this situation, the swing fall injury becomes just as serious as falling the same distance straight to the ground. He not only needs to be rescued, but he also needs immediate medical attention. You can reduce your potential free fall distance by using a self-retracting lifeline. When anchored above your head, a self-retracting lifeline extends and retracts as the worker moves about his recommended work area at a normal pace. But if a worker steps out of his safe work zone and a fall occurs, the speed sensing brake will activate, stopping the fall within inches and reducing the forces imposed on the body in most cases to 900 pounds or less. In this situation, chances are very good the worker may be able to rescue themselves, and the potential for injury is reduced. However, if the impact indicator on the SRL's snap hook has been impacted, the SRL must be taken out of service and sent to an authorized repair facility for recertification and repair.
In training for rescue, just like with fall protection equipment, it's going to be dependent on both the scenario and the equipment that is selected as appropriate for the scenario. However, one of the elements of rescue training that is a little different than fall protection training is that once you train people in the proper procedures, even if it's a very simplistic methodology, such as a simple ladder, or we're going to use a scissor lift to retrieve the worker, as long as it follows the policies and procedures that we lay out and the planning, and everybody's communicated and understanding. But when you get into some of the more technical elements of rescue, and there are many, is that those rescuers need to be very, very adept at what they're doing and be prepared to make changes to that plan based off of when an event happens or an incident occurs. Although yes, we can predict a lot of it, there are still unpredictable things that may occur. So they might have to modify that plan. So they have to be super knowledgeable, as well as this is not thought process, this needs to become muscle memory. So one of the encouragements for rescuers is that they regularly practice in a safe environment the skills so that when the event occurs, that they're not thinking about what the procedure is. They are absolutely able to react and react safely to retrieve that worker from this at heights, oh my gosh condition. In any rescue scenario, fall arrest scenario where we could potentially have a hanging victim, rescue is essential, not because it's a law, because you have a potential hanging victim. Depending on the standard or study that you look at, the average amount of time a victim has to remain in suspension is around 15 minutes. Of course, using suspension trauma straps or other devices such as that can increase the amount of time that the victim can remain in that condition awaiting the rescue. But if we're not prepared, people are humans and they're going to do what they need to do and they're going to get laser focused. So there's a bunch of different ways. I always use the KISS method, keep it simple. Using a simple ladder, a boom lift or a scissor lift to retrieve the victim, as long as it's the right tool for the job, then that's perfectly acceptable. But at times we have to get a little more technical. So in this next demonstration, we're going to take our victim and we're going to start down here on the ground. We're going to climb up into the air, remain protected. We're going to get the rescue equipment remotely attached to them, lift them up enough so that we can disengage them from their anchorage and lower them down to the ground to safety, because most of the time going down is where your rescue or your medical professionals will be. But there are times that going up is a necessity. So we have to look at the scenario to ensure that we have the right tool for the job, same as any fall protection equipment. All right, once the victim has fallen, at some point somebody's going to scream, somebody's going to make the call that we have a victim. And then of course the rescuer should remain calm, cool and collected and always be protected. The rescuer's number one priority is still the rescuer at all times. So we're going to get ourselves up there and we're always going to talk to the victim and make sure the victim's okay, and then we're going to direct the environment. So we're going to tell somebody to call 911 and then we're going to make sure that people are on point. So once we get climbed up here, we'll get protected and we'll talk to the victim. All right, victim, how you doing? Don't worry about it. Looks like you're having a pretty bad day. Let me get connected and safe up here. We're going to get you down somewhere pretty darn quick. So every rescue piece of equipment that uses mechanical advantage must have a minimum of a 3-to-1 mechanical advantage. So as that's a little further than I want to be for that swing fall, let me get connected to here. So as our victim's dangling there, we're just going to continue to talk to him, make sure that he's okay. Then I'm going to open up the bag. I'm going to reach back in, make sure everything's secure. Come out here, grab it, take my sling or whatever anchorage that I need to be necessary to get this attached, get it functional, get it over there, get it close to him, get it attached to me. And then we're going to start what they call measuring rope. So we're just going to measure out the rope down to our victim to make sure that we can get it attached. This type of rescue is so that the rescuer can remain in a safer environment and remain up here instead of rappelling down and attaching to the victim. There's numerous versions of this bad boy or this type of system, and they're all pretty good. They're all effective, but what makes it most effective, and will always make it most effective, is having very well trained and well practiced rescuers. The whole goal is to have those rescuers ready to go and hopefully never use it. If we're doing our fall protection well, we're going to be prepared for all kinds of scenarios. Now once I've measured out the rope, grab my remote pole like this, get it pulled through. Woo-hoo. Then we're just going to bring the rope up here and get it connected. Again, this is a system. There's a lot of different systems available. But you can see where if you're not practiced, you're not aware of what's going on, or you get in a rush where this can go badly. Because if I drop any of this stuff and I can't retrieve it, my rescue capabilities have just significantly changed. So this little device is just a remote device that is designed to attach to the rope so that I can remotely attach it to my worker's D-ring, get that attached, get it popped up here, get my pole out of the way. Then we're going to start pulling slack out of this thing. We're going to raise him up just enough so we can get him disconnected from his lanyard, because you don't want to just cut it. And we're just going to bring him up a bit. Just enough to get some slack in his anchorage or his lanyard. Then we're going to tell him rope down so I don't hit him with the rope. Attach it like this. And we are just going to slowly, using rope control and the brake, rappel him down to the ground. And then we're going to have somebody on the ground receive him to make sure that he doesn't just try to run away. But once he's down on the ground, now he's no longer hanging in suspension, no longer waiting for that 15-minute, that restricted blood flow. And he's back down on the ground, and we're safe. In some rescue scenarios, it doesn't have to be highly technical, it just has to be highly effective. So with using a rescue ladder like this that we're going to show, you're going to see where something very simplistic can be effective. So we have our victim Dan down there, and as he's waiting for his rescue to occur, he's going to use his trauma straps, so that way he's not hanging in suspension for any prolonged amount of time, relieving that tourniquet on the femoral artery. Once he gets established, we'll actually deploy the ladder and show what's going on. Dan, you all set? How you doing down there, man? You ready to get out of that position? Yes, all right. So a rescue ladder such as this, it's a pretty simple device. There's the instructions right on it, and one of them is open the bag, and of course then it says reach into the bag and get out your equipment. So at this point, in rescue, we want to look for an anchor that's at least 3,000 pounds strong or 5 times the weight of the worker. In some cases, if you can attach to the same anchor that's just fallen off of, that is perfectly acceptable as well, as long as it's in good condition. So at first, I'm just going to connect the ladder like this, and then I'm going to drop the ladder down. And I'm going to, of course, let my victim know that it's coming. So what you're going to see, Dan, is I'm going to drop this orange bag by you, and I'm going to try not to hit you with it, all right? But you're going to see the ladder come down. To your right, to your right. Okay. As the ladder deploys out like that, Dan can easily reach over and grab it, and then he can just stand up in the ladder. Even if he was incapable of climbing at this point because he was freaked out or anything like that, don't climb up just yet, my friend. He is at least no longer hanging in suspension. He's standing on something, because it ain't so easy to climb these. But each one of the rungs is reinforced, and he can easily do this. But this system actually has one other benefit, and it's called a belay system. So we're going to drop the belay down to Dan, and we're going to ask Dan to attach the belay system, or this device, which is nothing more than a carabiner, attached to a rope that's attached to the rescue ladder, and ask Dan to affix this to him. Hey Dan, can you reach that? Can you get that sucker attached? Wait, it'll come back to you. All right, go ahead and attach that to your D-ring, man. The idea here is that as he tries to climb up, whether he's coming all the way up, or we're just climbing him up enough to get him disconnected from his anchorage, we don't want him to have another fall, because climbing a ladder can be a challenging thing after you've just been a fall victim. So all we're going to do is pull the slack out of here. Now, this is a one-to-one mechanical. I can't lift Dan. However, as Dan climbs, go ahead and ascend a rung there, Dan, and as he climbs up, all I'm doing is continuing to pull slack, because if he accidentally loses his grip or his balance in any way, or leans back too far, go ahead and Dan, go ahead and let your feet go for a second. Dan doesn't have another fall. And Dan, how many rungs have you climbed now? 2. 2 rungs is enough to create enough slack in his system so I can get him disconnected, and then I can drop it and I can lower it. Dan, to your left. To your left. So drop that sucker down. Now, Dan, do you want to continue to climb up, or do you want to climb down? Okay, can you get your feet back on the rungs?
Yes, sir.
Beautiful. All right. Give me a little slack. Step up. There you go. A little bit more. Beautiful. Go ahead and climb down, buddy. Go ahead and climb down. And as he continues to climb down, all I'm going to do is this, and if he pulls too hard, it'll pull out of my finger and he'll be arrested just like that. So he pulled it out of my finger because he went too fast. Go ahead and step up, Dan. Let me get a little slack from you. Beautiful. You can climb back down now, man. And then he can climb back down and he touches the ground. Give him a little slack. And again, now our victim, in a very fast, effective, and efficient manner, is rescued from his hanging position.
With the necessity of inspecting equipment, if a fall occurs, all the equipment, the anchor, the body harness, the connecting device, shall be immediately removed from service. It is highly recommended that if you have a successful fall, that you contact the manufacturer of the equipment being used, because many have policies that they will replace fall-used equipment 100% free of charge, only with a little bit of paperwork and understanding of how it was used.
Let's talk about fall protection. Here's the system that works really well for us. It's all Super Anchor safety components. At the ridge, I have a tie-off strap with a D-ring. It just loops the ridge. It has a chafe guard. Inexpensive, easy to install, easy to uninstall, and reusable. So what I like to do is I set all my sheets and tack them, then I'll come back and nail them. In this case, I've got a block line there, so I'll snap a line and I'll come through and nail that. I nail them off as I'm waiting for that piece to be cut. But you'll notice that my rope comes from above, my hose comes from below. I always run the hose at the eaves. Then also notice that I am not adjusting the rope grab at all. The reason for that, of course I am hooking onto the hook of my nail gun. The reason I don't have to adjust it is because I set the length of the rope grab to that last piece of sheeting at the eaves. Now I'm in fall restraint for the entire day.
Thank you for taking the time to learn more about workplace safety. We're glad you're here. First things first, if you haven't taken the Fundamentals of Fall Protection course, we strongly recommend that you take it before proceeding through this course. With that being said, over the next few minutes, I'd like to fill you in on what's coming up in this online course on fall protection for roofing. Overall, this course will take about 2 hours to complete. It's divided into 5 modules, each covering a different aspect of fall protection as it relates to roofing. This course is designed to ensure you have a solid foundation to build or manage your own fall protection program, or begin using fall protection on the job. It's not designed to be a replacement for your company's fall protection training, as it does not meet all requirements. However, we recommend that you use this course as a supplement to enhance certain aspects of your training program. For your convenience, each video in this course is available on our website and our YouTube channel. We interviewed knowledgeable users of fall protection as it relates to roofing to provide an opportunity to present this information to you. We begin by discussing common hazards and why fall protection is important for roofers. We cover the basics of selecting the right equipment for the job, proper usage, inspection, maintenance, and training. Once you've completed this course, there are 4 other courses in the Fall Protection Suite to choose from. These are Fundamentals of Fall Protection, Fall Protection for Construction, Walking Working Surfaces, and Ladder Safety, which we highly recommend you take ladder safety in conjunction with this course.
Our company safety policy is very thorough. It's evolved over the years. I mean, it started just pretty basic stuff, a lot of stuff we've taken from OSHA, from other roofing contractors that we've talked with over the years of what we liked, what we don't like. And then we're very strict, and then we'll fine tune our policy. So we always try to be stricter than OSHA's laws just to be kind of a step ahead. And for us, I don't like to have any gray areas. I'd rather not be, hey, you can use fall protection here, but not over here. Granted, now the law is all-time or full-time fall protection. Our written policy is very thorough, and we want it to be as clear as possible for the employee, because we really want them to understand it. We want them to be able to, one, follow our policies, but ultimately be safe. That's our whole goal behind all of it, is have, our employees be safe every day. We have a management team within our company, so we can, all the leads get together and we talk and we bounce ideas off each other, what works, what doesn't work, and that's with everything in our business. But safety is always a big topic. And I can sit in my office and read a book and go on a website and go, hey, this looks awesome, but the crew's going, no, that's just not gonna work. It's not realistic out in the field. So input from the crews is very, very important to us, because that's where it's getting used. And we want it to work, not just, look cool on a website and go, wow, this is awesome, but you get it out there and it doesn't work. So yeah, getting input from them on a regular basis with everything that they're dealing with is very important to me, because that's where it's going to be most effective. Our safety policies have changed over time just by getting better, by new products coming out, different types of fall protection systems that are more safer and easier to work with. And so it just kind of naturally changes yearly, and it'll probably change next year too, depending on what we learn we think's the weakest link and how can we improve on it. So it's always going to change, with the components that we use. But as far as for us, we're 100% tie off at all times, period. So, that's pretty clear and cut and dry, and that's not going to change. It's just going to be, what tools we want to use. Well, I think anybody that's worked on a roof, you understand that the entire roof's a hazard. When you're up there on a slope, you can slip on something, you can step on your rope and put you on your back, and here you are sliding down the roof. And so there's a lot of obvious hazards. One, being so high up on some cases, having skylights, open windows, if you remove them to put a new one on, it's a hazard to fall in the home. Rotted wood, when you're tearing off a roof, the unforeseen stuff that you don't see, you tear off the shingles, next thing you know, you got delaminated plywood, and guys will step through. That's happened to us multiple times, where guys, luckily haven't gone all the way through, but you'll scrape your leg or bruise yourself pretty good. But I think everything on a roof is hazardous. Once you step off that ladder, or I should say, once you step on that ladder, you need to be paying attention and ready for anything.
We had a kid fall in Seaside, and he fell about 45 feet. He was 30 years old. You know how long it took to ruin the rest of his life? Probably less than 2 seconds. And they don't do that math. His kid fell a long way, broke a lot of bones, but less than 2 seconds. And it's all changed.
Metal roofs are probably the most prone for accidents because of the sharp edges and having to cut and detail with those. And the slip hazard on metal roofs is a lot more, is a lot higher for slips on metal roofs. When it comes to the slip hazards, it's really a hard thing to work with. You can't really do much. They do have some shoes that have a kind of a felt pad on the bottom of them that help with that a little bit, but when it gets really dusty in the summertime, it really makes it hard to work on. So really just planning your work so that you're not having to go back over things is really key. Giving the employees gloves so that they can cut and work around the metal and minimize the chance of cutting their hands and fingers is really a critical point with that too. And learning proper methods of cutting, because there are right and wrong ways to cut metal. And if the employees learn the right way, then that can help reduce a lot of risk as well. As well, we look at the heat in the summer months, really are a critical time to watch out for heat exhaustion, as well as dehydration with the crews working. So that is one of the things that we go over in our safety meetings a lot, starting in May, June, July, August. We go over that, things to look for with heat exhaustion, things to look for with dehydration, making sure the crews are taking their breaks so they can hydrate themselves. We've actually gone through steps where we provide the electrolyte little pouches that they can add to their water to make sure they're getting the electrolytes and the water they need. When it comes to working on the roof with the different materials, whether it's asphalt shingles or metal or tile or slate, there's different aspects for each one that you have to be careful of. Asphalt shingles, when it gets hot, they really hold the heat, can really, enable that dehydration and heat exhaustion to happen. They get hot, you can burn your fingers a little bit. The granules though are pretty rough, and so you can actually,
You lay enough shingles, you can actually wear through your skin. Putting those down. Wintertime when they're cold, they're stiff, they're rigid. They can, if the wind starts blowing, I have been on roofs where the wind will actually grab the shingles and start popping them on you. So one of the things that we also look at as far as the safety of a job is the power lines. If there's a power line that's running right up close to the roof, or if it runs across the roof, if it's anywhere one of our employees could actually touch it or bump into it, then we have the power company come out and they put their protective shrouds over the line. So really all aspects of roofing have an inherent danger to them. It's just making sure you get set up to give your employees the best safety practice possible.
Fatal work injuries. In 2017, 91 roofers died on the job. Of the 91 fatal work injuries, 82% were due to slips, trips, and falls. Bureau of Labor Statistics. Accepted claims. In 2017, there were 5,780 resolved claims in Oregon that were due to slips, trips, and falls. The average cost for these claims was $23,570. Oregon Department of Consumer and Business Services. Accepted claims. Below are a few categories of accepted disabling workers' compensation claims from Oregon between 2013 to 2018 due to falls to a lower level. 2,258 from ladders, 329 from roofs. Oregon Department of Consumer and Business Services. NIOSH Heat Exhaustion App. Scan the QR code to download the NIOSH Heat Exhaustion App.
When it comes to the equipment that we need for a job, for the safety equipment, price isn't really the factor per se. I mean, price is always a thing to take into account for, but usually we look at the installation, the ease of installation, the performance of the equipment, of course, making sure that it meets OSHA requirements, but then how the product is going to look if we're going to leave it on a house, on a residence, making sure that it's not going to just stand out like this Eiffel Tower that's going to be there forever. We want it to be low profile, but we want it to be accessible. We want it to be accurate, and we want it to perform the way that OSHA wants it to be. We buy fall protection buckets every week because it's cheaper to buy the bucket than it is to buy the rope. And so we get a new harness every time, a new bracket every time. We'll take the rope out, give that to the employee, and we'll save the other stuff for another time. When it comes to your anchors, there are a lot of options to choose from. And again, you have to choose the right product for the right installation and with the right customer, the right project, because you don't want to put a 18-inch tall, standard flat roof bracket on a pitched roof because that's not OSHA compliant. And so again, you got to match the product with the project and then with the customer. One of the other aspects of OSHA that we have used in our company to enhance our safety program is the pre-job consultations. So OSHA will send out a consultant to do a walk around of a job with you and to help you recognize hazards and what the appropriate fix for those hazards are. And so it's a very nice offering that OSHA gives for no charge, and you can work with that consultant to really bring about the best safety practice for that job, for your company, and for the public as well.
We'll break it again into commercial versus something residential. Commercial roofing, we see fall protection systems being used quite a bit, whether it's guardrail systems that go around the outside of the structure so that we're protecting everybody on the inside without having to put up active fall arrest equipment. We also see roofers more and more often working with building owners to put permanently in place anchor points and maybe permanently installed horizontal lifelines so that it protects not only the workers while they're doing the roofing, but we have fall protection for maintenance or other activities that would be happening once the roofing is done. We see counterweighted anchors that are brought up to the roof. There's also mobile anchors that I've seen that can go on the roof and provide anchor points for traditional fall arrest systems. I've seen a lot of fall restraint systems being used in commercial low slope roofing as well. So there's a lot of different things that I see our commercial low slope roofers using, and a lot of people are doing that fairly well. When it comes to the residential side of roofing is where there's a lot of work that can still be done and a lot of methods that can still be looked at. The perception, I think, in a lot of the residential roofing is, I'm only going to be here for a couple days. The systems that I would be putting in place are going to slow me down or actually increase the hazard to my workers rather than decrease the hazard. I also hear a lot from residential roofing that if I invest in the right methods and in the right solutions for my workers, now I have to charge more, and the people who are trying to get by and that aren't going to implement these same levels of protection are going to make it so that I can't compete in the marketplace. They're either going to drive the price down to where I can't get jobs, or they're going to cut into my profit margins so that I can't stay in business. The truth is that in residential roofing, we have to do a much better job across the board. We have to make sure that that industry is aware and educated about what the hazards are and what the solutions are. They have to know that there are solutions that can go on the roof that are temporary, that aren't going to penetrate the outside of the roof or cause a risk for water intrusion later on. There are very temporary disposable anchors that they can use on top of the roof, so when they're finishing and they're putting the ridge cap on at the end, they pound the anchors down and they ridge cap right over the top of them. Nobody knows they were ever in place, but as soon as there was any sheeting on top of that roof, they could have anchors that were put in place. There are systems that can go up on the ridge of a roof that hold more than one worker. You can have systems that can hold up to 4 workers off of one certified anchor point or engineered style anchor point. There are also horizontal lifelines that can be temporarily installed on a roof that allow workers to move back and forth across the roof, connect more than one worker up to 2 workers, and use the ropes and rope grabs up and down as they're going from the eaves up to the peak doing that roofing. Provides a lot of mobility. They can set up a fall restraint system very easily that way. If the companies that are involved in this residential roofing really take a look at what the roof is, how it's laid out, and plan for their fall arrest so that they don't have swing falls off the gable ends. There are ways to set these systems up so that maybe we're working in more restraint than we are in fall arrest. Could it take longer to do the job than it would without having any protection? Probably so. Is it going to mean educating themselves and their workers to the hazards and how to properly set their systems up? Absolutely. But it is definitely the right thing to do, because when we look at the injuries and the falls and the fatalities from falls from heights that people are falling from are right around that eave and ridge height on single level residential homes, which leads me to believe that we see a lot more falls off of the residential sector and a lot more injuries than we are really in the commercial side of things, where it's being policed a little bit more, where we have more safety professionals that are working in that area. In the residential side, we probably don't have the same level of safety professional in many cases, helping them and educating them to the hazards and how to do things correctly.
So on the residential roofing side of things, most of the work that we do is re-roofing. So it all starts off when our estimator, our consultant, goes out to the job. One of the first things he looks at is the roof itself, takes a look at the pitch, takes a look at the height, and then we will meet with the customer, kind of go over what they're wanting to do. And so our estimator will put that proposal together. As part of that proposal, he takes into account the time it's going to take to set up the safety lines, set up fall protection, tie-off points, whether we need to set up protection for the public, if it's a if it's a residential apartment complex, something like that, and you've got multiple tenants, then we will set up safety perimeters for the ground so that the public can't walk into those areas where debris is getting thrown. But then most importantly is when we set up for the crew, when the crew goes up on the roof and they set up their fall protection, putting those tie-off points. So that's all part of that estimating process that the estimator goes through. And then when we get to the job, to start the job, we will go over that same review again with the crew to make sure they know this is where we want the tie-off points, this is where you need to be a little bit more careful with the public. This is the customer's driveway. We want to make sure their cars get pulled out so that we don't have any chance of hitting anything there. And then setting up with the crew, and the foreman has the overall decision if there's something that the estimator might have missed, but we need to have it out there for fall protection, then the foreman gets that taken care of. The other aspect that we work with when it comes to general contractors with new construction are the pre-task safety plans that most general contractors require as part of their documentation. So before we start the job, we fill out what our safety plans are, and then the general contractor has a copy of that in his files. In that pre-task safety plan included typically is the fall protection methods that we're going to be using. They also review extension cords, power tools, anything that gets plugged in, having a weekly check of those. And so the pre-task plan, it can include as much as even parking, where you're going to park your vehicles. Pre-task plans typically include your HAZCOM, your data sheets for the materials that you're going to have on the roof, where that folder is going to be located at, or where that information is going to be located. So that is all part of that pre-task safety plan. So for us, the hazard analysis begins with the estimator or consultant. When he first goes out on the job, if it's a re-roof situation, he will conduct that first hazard analysis and have that as part of his estimate. And then as the foreman is working on the job, they will make adaptations or corrections as the job progresses and different hazards will show themselves. Because the more you look at a job, the more you'll find, the more potentials you'll find for hazards. So for us, we feel it's very important to start at the beginning, and then that continues all the way through the job. Weather can definitely play a huge factor in the hazard analysis with what's going on. When the estimator goes out, it might be a beautiful sunny day, and then the first day the crew shows up, there might be frost on the roof. At that point, the hazard analysis and the safety situations change. The foreman will make those corrections to make sure that everything is in compliance.
Well, I take my foreman out and then we walk around the buildings. We see all the hazards. We usually go and see what kind of equipment we're gonna need, safety and all that stuff. And then I tell him what I think we're gonna be using, and then after that he tells me what he thinks is the best, because they are the ones gonna be working on the roof, because they're using that every day. So yeah.
Supervisors in our company play a huge role in ensuring safety with the crew. They've been trained by our safety director, and they know our policies inside and out, what's right, what's wrong, what we can and can't do. And so when they go to the job site to check on the progress of the job itself and talk with the homeowner, part of their checks are checking on safety, making sure that their anchors are set properly, that their ropes are hooked up, ladder safety, the whole gamut of safety items that we look at. And so there are eyes out there when our safety director can't be there. And if they do detect an issue, they're going to change it with the crew right then and there. Say, hey, this is what needs to be done. And then they will report to our safety director to ensure that he knows what's going on, what crew it was, what employee was, not being safe. If it's a major issue, the supervisor will contact our safety director immediately and get out there, and he'll address the situation. But the supervisor will pull the guys off the crew to take them out of that safety hazardous scenario. We have a lot of crews, so the safety director can't get to every single crew every day. We definitely see the crews at least twice a week, every single one. But he'll grab 3 to 5 a day and go out and look at the entire job, all the safety when it comes to fall protection, to ladders, to where's our dump trucks and trailers placed, just the overall safety on the job. And he takes a lot of pictures. And then works with the crew if there are any issues, fix the problem right then and there. And then he puts together a full report with the pictures of what was good and what was needs improvement, and what discussions he did have with the crew and the employees. And then he emails this to me daily so I can review, and then we put together a plan at that point if one's needed.
When a worker finds a hazard on the roof, we empower our employees to take care of the issue right then. There's no reason to take the time to go tell somebody else and wait for that to get fixed. So we empower our employees. If there's a skylight that is, on the roof that was not noted, that needs to be covered up with a sheet of plywood, that employee right then will communicate to the foreman, but at the same time, he's going to get the sheet of plywood to replace that, or they are going to get that sheet of plywood to cover that skylight.
Every house is a little different, and so that's the big thing. Different than when you go to a factory, everything's the same. But when they show up to work, it's every day is going to be different. So what does the roof look, the pitch of it, where it's located, how many trees are around, power lines, all that kind of stuff. They've got to look at that each day because it's always changing. And then making sure that we can provide fall protection anchors where they need them and where they will be the most effective and not causing issues for them. So really kind of taking a look at the roof up front, getting ideas from the estimators, even if they notice something that's kind of tricky, that we have the time to put together plans before the crew shows up so that we can provide them with the assistance, with the support, with showing where these anchors are, maybe.
Oregon OSHA's workplace safety and health rules only allow workers who have successfully completed appropriate training and evaluation to operate forklifts. This video covers how to operate a forklift safely, along with important procedures, so you can use yours safely and efficiently. It applies to experienced operators and first-timers alike. Keep in mind, this training will not cover every detail of forklift operation, but focuses instead on safety applications. There are many different forklift models made by a number of manufacturers. Be sure to also study the operating manual and become familiar with every kind of forklift you operate. A basic inspection of your forklift at the beginning of every shift is essential. Regular inspections can prevent breakdowns and surprises. Ideally, an inspection is written and includes some kind of checklist. Consider using an app to easily create records. A paper trail of maintenance procedures can help minimize liability if someone gets hurt. But if that's not feasible or in alignment with policies at your workplace, at least do a thorough visual inspection before each shift. Here are some things you might look for. Is there oil or liquid underneath the machine indicating a leak? Are hard tires in good shape, or are they cracked, worn, or damaged? Are pneumatic tires properly inflated? Are lug nuts in place and tight? Are lights functioning properly? Is the fuel tank secure with no signs of leaking? Do you have fuel in the machine? Are hydraulic hoses in good shape and not frayed or leaking? Always conduct this check visually. Never touch hydraulic hoses that may be under pressure. The hoses can have sharp, frayed wires. The oil can be hot, and in extreme cases, a pinhole leak in the hose can cause oil to shoot out under high pressure and inject under your skin, causing severe injury. Are the forks in good shape, not cracked, bent, or otherwise damaged? Are they set how you'll need them to be for the job you're about to perform? Are the chains in good condition, with no sign of missing pins or bolts? Is the operator's manual and weight capacity placard in place and readable? If there is a fire extinguisher on the forklift, is it ready to be used? Is the seat belt extending, retracting, and latching properly? Is it damaged? Once you get on the machine and fire it up, are the brakes holding and stopping as they should? Does the steering function as it should? How about the tilt and lift functions for the forks?
Stop and ask yourself, does everything feel right, sound right, and smell right? If not, stop and investigate or tell your supervisor. There's never a job so important that it's worth using a machine that isn't functioning properly and might be unsafe. Damaged or malfunctioning equipment should be tagged out according to your employer's lockout-tagout procedures.
Always turn off the motor before fueling, and do not restart it until the fuel tank cap has been replaced. Check to make sure you're using the right kind of fuel for your forklift. Wear eye or face protection and insulated gloves anytime you handle propane to prevent being injured by a leak. Electric forklifts are increasingly common, and they're advantageous because there's no fuel to handle, and they don't create hazardous exhaust gases. Charging stations need to be protected from damage by a strong barrier or by placing them away from the path of travel. If a fork can do this to a structural steel beam, think of what it can do to a high voltage charging block. Every forklift has a designated weight capacity displayed on a placard that is visible from the operator's platform. Exceeding that weight capacity can be extremely dangerous. If you're unsure of the weight of the load that you're about to carry, test the stability of your machine by lifting the cargo slightly off the ground and moving your forklift a short distance and then applying the brakes. If the back end of the forklift starts to come off the ground, or your steering is less responsive than normal, your cargo is likely too heavy and should not be moved. Keep your cargo as low to the ground as possible, centered on the forks, and as close to the mast as possible. By doing so, you can avoid tipping forward. You may find it easier to get underneath the cargo with your forks tilted down a little. Once the load is on the forks, tilt the mast back when possible to keep the load from sliding off. Drive in that tilted back position until you get to the area where you plan to unload. Most of us have experience driving cars or trucks, but forklifts steer, handle, and feel very different. Rear wheel steering allows the machine to maneuver through compact areas, but can cause the rear end to swing side to side, potentially striking walls, beams, vehicles, or people. Driving with rear wheel steering can take getting used to. Smooth steering is key. When traveling, keep the forks as low to the ground as possible. That height might vary with your terrain. When driving on flat, smooth concrete, they might be 2 inches off the ground. And when driving up a bumpy hill, they might need to be 10 inches off the ground. But keeping the forks as low as possible will help keep the machine stable. When traveling down a slope with cargo, turn your machine around so that your cargo is uphill. This likely means driving in reverse. While driving in reverse, turn yourself around in your seat and face the direction of travel. If traveling up an especially steep hill, Consider driving backwards to prevent your forks from potentially sticking into the road ahead of you. Avoid driving diagonally on a slope across a grade. Turn and stop smoothly. Sudden stops can cause your cargo to shift. Be aware of your cargo. Cargo that is unstable and shifts or falls while you are pulling or carrying it can affect the balance of your forklift or potentially strike and injure others around you.
Sometimes your cargo can obscure your vision of your path of travel. This is dangerous. The temptation might be to hang your head out the side of your forklift to see around your cargo, but this is not the right solution. You can still only see half of your path of travel, and you're outside of the cage protecting you from falling objects or obstacles. And odds are, if you're hanging out the side of your forklift, you're probably not wearing your seatbelt. So what can you do instead? Frequently the answer is to drive in reverse, but as mentioned, this doesn't mean to just glance over your shoulder and go. You need to turn around in your seat and face the direction of travel the entire time you're driving in reverse. Sometimes driving in reverse isn't an option. Maybe you're loading a truck or container, or maybe you need to set your cargo at the end of a long, narrow hallway. If you don't have the option to drive in reverse, think about using a spotter, getting off the forklift and scouting the area you're about to drive through, or just move less cargo at a time and take multiple trips. What you don't want to do is to simply say, well, I can't see, but here I come.
When parking, make sure you lower your forks flat on the ground. Even if the forks are lowered most of the way, they can still present a major tripping hazard. Put the forklift in neutral and set the parking brake. Block the wheels if it's on an incline. Be mindful of your surroundings and park your forklift in an area that is not blocking any fire extinguishers, emergency eye wash stations, first aid kits, fire exits or stairwells, breaker box panels, or any other areas that someone might need to get to in a hurry. If you're just stepping away from your forklift momentarily while the engine is running, make sure to stay within 25 feet of the forklift and keep an eye on it at all times. If you can't stay close and see it, then you need to park and shut down your forklift. Be careful while climbing on and off your forklift, and always maintain 3 points of contact. Remember, 3 is key. Slips, trips, and falls are one of the most common workplace injuries. Avoid climbing on and off the side of the forklift where your fork controls are located. It puts you at extra risk of bumping a lever and inadvertently moving your forks or cargo, potentially causing an injury. You must be at least 18 years old to operate a forklift. Drive at safe speeds. This includes adjusting your speed for your conditions. Decreased traction, uneven surfaces, larger or less stable loads, impaired visibility due to poor lighting, operating in tight quarters, and pedestrians might require us to slow down. Whenever possible, try to keep at least 3 truck lengths distance between you and other forklifts. When approaching blind spots and intersections, warn others by sounding your horn. It's especially critical when driving into and out of buildings or containers where people might not be able to see you coming. Avoid unnecessary use of the horn to prevent overexposure and loss of awareness by those who work in forklift environments. Never pass other vehicles going in the same direction. If you want to race these machines, join an authorized forklift racing league. Always watch for overhead hazards such as power lines, especially while lifting the forks or cargo higher into the air. Experienced operators should take care to avoid complacency and continue to receive regular training. You will undoubtedly get faster and more efficient with experience, but your safety behaviors on a forklift should be the same whether it's your first day or your 20th year. Keep in mind that gas, diesel, and propane-powered forklifts generate carbon monoxide and other hazardous fumes. Operating them in enclosed areas with insufficient ventilation can create dangerous conditions for employees. If you plan to use your forklift to elevate another person, ensure the basket is properly guarded, secured to the mast, and in compliance with Oregon OSHA regulations. A significant number of forklift injuries happen not to the operator, but to pedestrians on the ground. As the forklift operator, it is your single biggest responsibility to maintain 360-degree situational awareness of your surroundings, including any pedestrians. With that said, if you are a pedestrian working around forklifts, it is in your best interest to make that job easier for the forklift driver. That means staying a wide distance away from active forklifts, avoiding distractions like phones while walking through areas where forklifts are present, and not walking up to equipment until the operator is aware of your presence. Pedestrian safety is a two-person job. Forklifts are extremely heavy, and their tires, especially hard rubber tires, are extremely unforgiving if a mistake is made and a foot is run over. As a pedestrian, you should never trust hydraulics. Forklift hydraulic systems can catastrophically fail and crash to the ground in a moment's notice, releasing the stored kinetic energy of forks and cargo in the air. Even in cases when hydraulics don't fail, operators can unintentionally touch levers and lower forks unexpectedly, crushing anything below. Pedestrians should never be allowed to walk or reach underneath elevated forklift forks. A forklift only has one seat and one seatbelt, and therefore should only carry one person. Never allow others to ride on running boards, steps, fuel tanks, or forks. Pedestrian safety vests are a great way to improve visibility, but may not be appropriate in every situation. Safety vests should be well fitted and closed, not hanging open. When working around equipment that may pose an entanglement hazard, the risk of wearing a vest may exceed any benefit of increased visibility. In these circumstances, instead consider high visibility clothing or straps, safety lanes, and physical barriers.
Pretty universally, when we talk to people that have run over and killed a coworker, friend, or family member, they tell us they would gladly trade places with them if they could. That's a difficult burden to carry for the rest of our lives. Ensuring the safety of others while we're operating equipment in the workplace should always be our number one priority.
If a trailer is attached to a truck, ensure that the truck brakes are set. Always check to ensure that chocks are in place behind the rear wheels, or, if present, ensure dock locks are in place and secured. These will prevent the trailer from potentially rolling away from the dock. If it's not attached to a truck, ensure the front of the trailer is supported with landing gear or a nose jack, and that the equipment used to support the trailer is in good shape and sufficient for the task at hand. Never improvise supports for the front end of the trailer with pallets, beams, or other objects. Check for damage in the flooring of the trailer. Also, check to make sure the dock plate is secure if appropriate. In some cases, lifting and moving cargo doesn't happen on concrete floors or gravel driveways. This is where rough terrain or off-road forklifts come into play. All the same principles of a traditional forklift still apply. Maintenance and inspections before use, staying within your weight limits, and being aware of your center of gravity, watching out for pedestrians, adjusting your speed to match the terrain, and everything else we just discussed. But a rough terrain forklift has oversized tires and higher ground clearance, which means they're often taller, wider, have higher weight capacities, and can be used in areas that standard forklifts could never operate. They present some unique safety considerations. That extra width of a rough terrain forklift means it takes up more space, and you have to be more cautious when operating in tight areas. The extra height can potentially raise your center of gravity and put you at a greater risk of touching overhead hazards. That increased weight capacity can make you overconfident in the lifting capabilities of your machine. They are frequently less maneuverable and may have decreased visibility. Working in fields or undeveloped areas might lead you to encounter bumps, potholes, ruts, and slippery or unsecure driving surfaces. You may encounter steeper terrain, drop-offs, and ditches. Take extra time and caution while operating these larger machines. If you follow all the appropriate safety precautions, you should be able to avoid ever tipping over a forklift. However, mistakes are made and accidents happen. You should have a plan so you know exactly how you're going to respond if a forklift tips over. Wearing your seatbelt every time you operate a forklift, whether you're driving it for 10 seconds or 10 hours, is one of the most important things you can do to keep yourself safe.
Do you know anyone who has successfully jumped off of a tipping forklift without injury? I do. It can be done. Sometimes those people even say if I hadn't jumped off when I did, I might have been hurt or killed. And if I'd been wearing my seatbelt, I wouldn't have been able to. But it's important to draw a distinction between anecdotal and empirical evidence, a couple of people's stories versus statistics and data. While I know a couple people that have successfully jumped off of a tipping over machine and walked away from it, I know of a lot more who tried and failed. The statistics very clearly tell us that if our machine is going to tip over, the safest place for us is inside the roll cage with a seatbelt on. If you feel like your forklift is going to tip over, never jump from the vehicle. Instead, grab onto the steering wheel and brace yourself. Your instinct may be to grab onto the wheel and lock your arms out, pushing yourself backwards in your seat. While this might make sense if our concern was a frontal collision, really it isn't ideal in a tip over. Look how much room there is for lateral movement. If this machine were to tip over, where's your head going? Into the bar or into the pavement? Instead, wrap your arms under the steering wheel, using your forearms and your biceps to pull yourself in tight against it. Look how much more stable this is. I couldn't push him out if I wanted to. This is the most secure position to be in if our forklift were to tip over, and it gives you the best odds of walking away from the incident without a serious injury. Plus, you get to show some love to the machine that does all that hard work for you and your crew.
Today we've talked about some basic principles of forklift safety. Pre-use inspection and maintenance. Fuel. Loading and moving heavy cargo. Parking. Remaining aware of your surroundings. Watching out for pedestrians. Loading trucks and trailers. Using forklifts on rough terrain. And what to do if a forklift tips over. But this video alone is not enough to complete your training. After watching this training, make sure you review with your team the specific equipment you'll be using, the jobs you'll be performing, the environments you'll be working in, and any unique hazards present in your workplace. Conduct testing with your employees to ensure the concepts presented here are understood, and then make sure each forklift operator completes a drive test so these concepts can be applied in real life. Make sure you keep a record that includes the operator's name, the training and evaluation dates, and the name of the person conducting the training and evaluation. Retrain employees regularly whenever you observe unsafe behavior or at the intervals required for your industry. While forklifts are powerful tools that can make some of the most difficult jobs easier and more efficient, they are also capable of causing terrible damage and harm. Follow the steps we've outlined in this training and visit our other resources on safe.com to ensure you, the operator, along with everyone around you, go home safely.
What if I told you that the single largest hazard to pedestrian safety in a forklift worksite is probably something that you have done in the past week? 1 in 5 serious forklift-related injuries involve a pedestrian.
and pedestrians oftentimes underestimate the severity of a collision with a forklift. Today's video is focused on the safety content knowledge that pedestrians must follow to keep themselves safe as they walk across the worksite or interact with forklift traffic on the job. Welcome to this Supply Chain Pros video. A forklift safety circle is an imaginary 3-foot diameter around a forklift that serves as a cautionary barrier for pedestrian and forklift interactions. If a pedestrian needs to speak with a forklift operator, the forklift must be stationary before the pedestrian can approach inside of the safety circle. During this interaction, the pedestrian should stand so that their feet are parallel with the forklift wheels and not perpendicular. In the event that the forklift operator begins to drive away, having feet perpendicular could lead to the lift running over a foot of the pedestrian. If wishing to speak with a forklift operator, this should always be done while the forklift is stationary. It can be tempting to walk and talk as a forklift driver and a pedestrian have a communal objective in another direction of the workplace. This violates direction of travel and distraction safety principles for the forklift operator and puts the pedestrian at an increased risk as well. Wait until the forklift is stationary to conduct the conversation. If a pedestrian finds themselves working closely with a forklift operator, always respect the 3-foot safety circle, over-communicate intentions, and err on the side of caution. Miscommunications and misunderstandings present a high risk of a collision between a pedestrian and a forklift when working closely. Never assume the forklift operator sees you, make eye contact, and wait for acknowledgement before assuming the right-of-way. Assuming wrong can have severe consequences. The following areas of a work site are considered high risk and should be treated with extra caution as pedestrians walk through the work site. Intersections are collision hotspots due to poor visibility and cross-traffic. Always stop before entering an intersection. Listen and look for forklift traffic, and only then can you proceed cautiously into the intersection. Congested areas can limit space for pedestrians as well as other forklift traffic as they navigate them. Objects can block the view of a pedestrian from other coworkers. Narrow aisles can limit maneuverability, and pedestrians should never walk side by side with a moving forklift. Forklift operators leaving or returning to a charging area may not be expecting pedestrian traffic near the chargers. Display extra caution when walking near battery chargers, near break time, or around shift change timeframes. Loading docks. Operators may have reduced control due to an incline, load shifts, or limited space on a loading dock. Pedestrians should never walk behind a forklift reversing off of a trailer. Finally, the highest risk area is a near-miss incident that occurred today, was not corrected, and occurs again tomorrow, resulting in an injury. Always report near misses today so that the root cause can be addressed and tomorrow's incidents can be prevented through training and awareness today. The best way for a pedestrian to ensure their safety at the worksite is to walk defensively. Defensive walking starts with a pedestrian's mindset. How has your mindset been this week as you walk amongst forklift traffic? Similar to defensive driving, defensive walking is characterized by constantly scanning your surroundings, using your eyes and your ears to understand and anticipate potential hazards that could impact you between where you are now and where you are going, making decisions that keep you away from hazardous situations like forklift traffic and congested areas. If there is a marked or designated pedestrian aisle, use it and stay in it. Be predictable. If you are required to walk near hazardous areas, ensure that you do so at a reduced cautionary speed. Always avoid rushing through the worksite. No objective is more important than arriving at your destination safely. Stay clear of raised forks and never walk under a lifted load, as the load could fall or the forks could lower at an unexpected time. Wait for the operator to complete the work at a height before approaching or passing. Avoid distractions like cell phones and earbuds that take your attention off of where you're walking and the hazards that could be in your path. And finally, make sure that you are wearing proper, well-fitting footwear. Anytime that a pedestrian walks across the workplace, they should ask themselves the following questions. Am I wearing high visibility attire? Am I walking in a designated walking path or a general forklift travel aisle? Am I walking in a highly visible area of the workplace? Am I aware of my surroundings or am I distracted? Are there any tools that I can use, such as hanging dome mirrors to understand my surroundings or a flashlight to help increase my visibility? Pedestrian safety in a forklift worksite is not about luck. It's about awareness, communication, and disciplined habits. Every step that you take through a forklift worksite is a safety decision, and small choices can carry serious consequences. Respect the forklift safety circle. Never assume an operator sees you, and slow down in high-risk areas. Walk defensively, stay visible, avoid distractions, and always choose caution over convenience. Remember, today's near miss can become tomorrow's injury if it goes unreported or uncorrected. Speak up and learn from close calls. Help to strengthen a culture where everyone looks out for one another. No task, shortcut, or deadline is more important than getting home safely. When pedestrians and forklift operators work together with intention and respect, the entire worksite becomes safer for everyone. If you found value in the content of this video, like and subscribe to the channel. This is your Supply Chain Pro, out.
It is critical that you know what to do in the event of an H2S or SO2 gas release. To make it easy to remember, we've assigned each step an identifying letter. The first step you must take begins with A, the second with B, and so on. So let's take a look at what you need to do in the event of a gas release, or what we call the ABCs of initial response. A is for abandon. You must abandon the area immediately and evacuate to a safe area. Check wind conditions and move upwind from the release or crosswind away from an upwind release. Remember, H2S and SO2 are both heavier than air, so higher ground may also offer some relief. B is for broadcast. You must broadcast the alarm and follow your workplace procedures. For example, sound whistle, horn, or call by radio. Call for help. C is for count and consider. Conduct a head count and assess the situation for other hazards. D is for don. Don your respiratory protective equipment. Always put on your SCBA before attempting to rescue fallen co-workers. E is for exercise recovery operations. Only once you've donned your SCBA are you permitted to re-enter the exposed area to remove victims to safety. F is for first aid. Administer first aid and CPR if necessary. Call for emergency services and continue CPR until EMS arrives. Ensure the individual is kept warm and remove any contaminated clothing. Keep conscious individuals at rest. Be aware of possible accompanying injuries. For example, if the victim's eyes are red and painful, flush with large amounts of clean water for at least 15 minutes. Ensure the workers receive medical care as soon as possible. The worker must not be allowed to return to work or other activities after being knocked down by H2S. G is for guide. Guide EMS by providing directions and information to medical services. Even if the victim revives quickly, they still require medical attention because there remains a danger that fluid may collect in the lungs. Arrange a transport of the victim to medical aid and provide the necessary information to emergency medical services. Now that you know when it's safe to rescue a co-worker knocked down by H2S, we should cover how to remove the victim to safety. If you are alone and conducting the rescue yourself, you can simply grasp the victim's collar and drag them to safety. Use your wrists and forearms to support their head. Check your travel path periodically to ensure it's clear. The obvious difficulty with this technique is that it requires that you walk backwards. Another method if you are alone is to reach through under the victim's arms, crossing and grasping both arms while lifting the victim. Although this technique allows you to stand more upright, you are still walking backwards and need to be aware of your travel path. With two rescuers, loosen the neckline of the victim's coveralls and each grasp a side of the coveralls with one hand and lift and pull in unison. With this method, rescuers can fully stand and walk in the forward direction, and the victim's head is supported by their clothing. Care must be taken to ensure the victim's clothing is loosened enough to prevent any pressure on the neck and throat. Another option with two rescuers is to have one rescuer at the victim's head and the other at the feet. Cross the victim's arms at their chest and overlap their legs. One rescuer lifts the victim by reaching through under the arms and lifting at the chest while supporting the victim's head against the rescuer's chest. The second rescuer lifts the victim at the lower legs and places both legs under one arm, leaving the other arm ready to open doors as they carry the victim to safety. So now that we know our ABCs of initial response, let's take a closer look at what to do in the event of an H2S release. When working in an H2S environment, a constant awareness of the wind direction is essential in or around the areas that could accidentally release toxic gas. The flags and windsocks will point in the opposite direction from which the wind is originating. For example, the windsock shown here is pointing to the east, so we know that the wind is blowing from the west. Wind direction is reported by the direction from which it originates. It sounds confusing, so let's look at a few examples. If the flags and windsocks are pointing south, then it would indicate a northerly wind. If they are pointing west, it would mean there is an easterly wind. Let's say you observe the flag on the main administration building and notice that it's pointing north. What wind direction would this indicate? We'll give you a few seconds to ponder this. You'd be right if you answered southerly. What if the windsock in the laydown yard is pointing east? What wind direction would this indicate? It would be a westerly wind. This time you were listening to the radio, and it reports that the wind is westerly. From which direction is the wind blowing? In this case, it would be blowing from the west. Knowing the wind direction and how it is reported could be essential in any accidental gas release situation. Obviously, the wind direction is not limited to the 4 directions we talked about previously, but you should now have a good understanding of how it is reported. If the area flags are pointing southwest, then this would indicate a northeasterly wind, and so on. But why is all this talk about the wind so important? Well, if there is a gas release, you need to get away from or abandon the area as quickly and safely as possible. You have to ensure that you are not running into the path of the toxic gas. Your goal is to get upwind of the gas, and you can't do that if you don't know which way the wind is blowing the gas. Keep in mind, though, that H2S is heavier than air, so higher ground is also better. When the alarm sounds, check the windsock, area flags, or trees to determine the direction of the wind. In this example, the windsock is pointing south, so you know it's a northerly wind which will be blowing the gas to the south. The gas release is to the south of your position, so to head upwind means you head north. If you are located upwind from a gas release, then continue to move upwind away from the release area. Let's look at the example again, but this time you are in a different location when the alarm sounds. From this position, the release is upwind of you. If you were to head upwind now, you would be walking directly into the toxic gas. Heading downwind is also not an option, since the gas will be blowing directly into your path if you do. The best option, therefore, is to initially head crosswind. In this scenario, heading west appears to be the best option. Your goal should be to get upwind of the release, but if you are located downwind, you will need to initially head crosswind away from the release area, then head north. If you are located upwind from a gas release, then continue to move upwind away from the release area. Never move downwind of a gas release. Here is an aerial view of a gas release situation. Imagine yourself standing in position 1. You are wearing safety glasses, a hard hat, and safety boots. The gas alarm just started flashing. In which direction should you head to safely abandon the area? If you said north, you were right. What if you were standing in position 2? In which direction would you need to head to safely abandon the area now? If you said west, you were right. This time you are standing in position 1 when the alarm starts to sound. You know your co-worker is lying on the ground in position 2. What would you do? Remember, you are not wearing respiratory protective equipment, so if you attempt to rescue your co-worker, you will also be knocked down. You must abandon the area immediately before attempting any rescue. The alarm is broadcasting and you've counted 1 worker knocked down. Consider, can you safely re-enter? You don your air pack and exercise recovery by getting to your co-worker and dragging or carrying him or her to safety. Then you administer first aid and guide emergency services. Every worksite will be different. Get to know the muster stations. If it's an H2S environment, get to know the location of the alarms. Locate the windsocks. Get to know the landscape. Ensure you have all of the PPE necessary. You may need personal gas detectors. If so, ensure you know how to operate them. Make sure you know the location of emergency equipment and air packs. Ensure you have the training needed to don and wear the equipment. When you are dealing with H2S, there are no do-overs. Resist running in to save a coworker that's just been knocked down by H2S until after you've donned your RPE. If it got them, it will get you too. This course covers the basics, but to become competent, you need practical experience. Never work in known H2S environments without familiarization training on respiratory protection equipment. Become proficient donning the equipment before your life or your body's life hangs on your ability to get it on in a hurry. Remember your ABCs, and don't take chances with your health and safety. Make sure you know the safe work procedures and be diligent in following them. Your family is counting on you to make it home safely at the end of every day.
Always remember safety first.